Hi students, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher. Everybody, let me know in the chat box if I'm clearly visible and audible to all of you or not. I'm so sorry for keep you waiting. Even I was waiting for the rain to end and so that power can come back and I can take your class because I really wanted to take today's class. I try my best not to miss any class, right? So that's the best thing about this channel, that we try our best no matter what is the situation. We try our best even if it is getting late. We try our best that if we have promised something, we will deliver that to you. Right? Okay, students. So how are you all? And today we are going to do periodic classification, right? Periodic table. So everybody, you can let me know over here in the chat box what is your class. You can see. Can you see the? Can you hear the lightning? Ma'am, no bangles. Usually I am like this only. That was because of some tradition that was going on in my family. That's why I was wearing that. But otherwise, you will see me like this only. Simple Diksha ma'am, right? Okay, you will see Diksha ma'am with these kind of bangles. These kind of bangles I would love to wear, right? You can make something out of that for me, isn't it? Okay. So, students, you can let me know in the chat box that what exactly you are in. Are you in 11th class? Are you in 12th class? Or are you a dropper who has done 12th and 11th, but right now they want to revise their class 11 chapters because they have so many backlogs. And those students who have not watched my video regarding the linked topics, right? You must watch that because there I have told you regarding everything, that what are the topics that you should do before starting 12th class. Now, students, the important part here is that why I have picked up this chapter, that is periodic classification. So, the thing is that in this chapter, you have knowledge about the atoms. My basic idea to let's learn this chapter, to talk about this chapter, first chapter on this channel for JEE 2026 is so that you remember the elements, you remember their atomic numbers, so that you are able to understand further chapters of organic, inorganic chemistry in detail, because in organic and inorganic chemistry it is required the most, right? Okay, so I'm going to start it. Ma'am, class 11th, is it for class C? This is basically any student can watch it, right? Class 11, class 12th or dropper, but specifically this is for those students who are in class 12th or those students who are droppers, right? Because, and it's not like it's not for class 11th. Class 11th, right now, I am completing this chapter within 2 hours or 3 hours, right? So for 12 students and for droppers, this will be a very good revision, right? But for the 11th class students, don't take this class as your final class, because we are going to take detailed sessions, right, which will take a lot of time. That will be beneficial to those students who are learning this chapter for the very first time, right? Some students already have learned it enough. They don't want to waste 10 hours doing the same chapter. This is for those students. Okay, yes. Now let us start that. This is basically, you can get that idea. This is for all the students who are preparing for JEE 2026 to complete your backlogs, to revise this chapter. This is the best session, right? So first thing is, Acha, how do you like this avatar? Is this a good avatar? Like, do you like Diksha mam like that or not? Or you like Diksha mam with bindi? Okay, so guys, that's my introduction to all the students who don't know me. Guys, I am masters in chemistry, right? And I have taught chemistry for past 8 years, right? And after knowing a lot of students, right? I have not only taught online, right? That's a different thing, but I have also taught offline. So the benefit of teaching offline is that I know what are the problems that you might be having in your mind right now, right? Okay, so I have taught students one-on-one also. So that's the benefit, that I know that what you are thinking right now. That's why students say that, ma'am, you always answer our doubts. Reason being, because I know that this doubt one student has asked me, right? So that's why we know that, okay, this doubt will be there in your mind. So directly only we try to answer those doubts also that will be there in your mind. Okay, yes. Now let us see periodic classification. So guys, this is a very small chapter, but this is a very, very important chapter. Now, I will start class 12 chemistry and come back to class 11th later. Periodic table is looking at you like this. What you are doing, bro? You are leaving me and you're going to start your class 12th. Brother, stop there. Why? Because if you don't know me, because what we think that, okay, periodic classification, arey, challa. Why? Because you are like, okay, periodic classification, not even a single question they ask. But in reality, block chemistry, full block chemistry, if you know this chapter, very smooth P block and DNF block will become for you, right? That's where you have to give importance to periodic classification, right? You have to give that importance, right? Okay, so now because it forms the base of inorganic and organic, as I told you. Now, let us see and start this chapter. And before that, don't forget to hit the like button and spam this chat box with green hearts. I want full energy, right? Don't worry. I'm not going to make this session boring for you. In between, we will have some fun session. We will have quizzes also in between. So just relax, right? And have full energy here. I don't want you guys, those students who are here, promise me that you will be here till the end of the session, right? See, everyone, trust me, everyone can start a chapter, everyone can start taking a dream, right? But there are only few students who are there till the end. It takes efforts, right? When you are there, when ma'am has full energy, you have full energy, you'll be like, okay, I'll watch this full lecture. Then what happens? Okay, now I want to go for dinner, right? You can have your dinner side by side. You are like learning from me. What's the big deal in that? So when you leave the class and say that I'll watch the recorded version, that's where you are losing your seat. So don't do that. If you're there in the live set, this is the time. This is that time which you can utilize. I can't say the same thing 8 months later. 8 months later, you will not have the time to sit in live session and see the full detailed versions. But right now, you have the time, so utilize it. You have already wasted class 11, but please don't waste the time for backlogs. Please don't do that, right? Okay, now let us start that. No more motivations, right? So first is periodic table introduction, table which classifies all the elements in accordance. So it's like when we want to classify few things, like we want to classify these are apples, these are bananas, these are oranges. That's how the classification is done. All these things are under fruits, right? All this potato, bhindi, and all these things are under vegetables, right? And what we are saying, milk products, this cheese, milk, all these are under dairy products, right? I have classified these things. So whenever I say fruits, automatically apple, banana, all these in your mind, right? So that's the same thing we want for periodic table. When I say group number 13, something should be in your head. When I say group number 14, you should have a number of elements in your head, right? And that's how we will classify these elements. But the history of classification of this element is very interesting, right? The history is that firstly you will have Dobrnyer tribes, then you will have Newland's law of octave, then you will have Mendeleev's periodic table, and the last one is modern periodic table, right? So one by one we will talk about all of them, right? One by one we will talk about all of them, right? First thing is Dobrnyer tribes. First thing is Dobrnyer tribes. So Dobrnyer tribes, see, first thing is from here and here, very rarely questions are asked. Most important is modern periodic table and this Mendeleev periodic table. These are the most important things for you, right? But we will go through everything, right? So when we talk about Dobrnyer triads, that means we are talking about the average atomic mass, right? In all these cases, we are talking about atomic masses. We are not talking about atomic numbers anywhere, right? Okay, we are not talking about any. Very good, very good. Hi Divya. Welcome. Thank you so much, Divya. Right? So you are the member of this channel now. I'm so happy about it. You all other students can also be the member of this channel. Hi, Divya. Okay, great. I'm so happy that you guys are that much, dedicated towards your classes. Very happy about it. right? Okay. So, for example, this is lithium, sodium, and potassium, right? Lithium, sodium, potassium. Now, they are saying the middle element will be the, now your JEE students here, you know this average, right? So, sodium will be the average of lithium and potassium. That means if you have A, B, and C, this B is going to be the average of first and third element, right? That is Daubernier triads. So you can see like in which of the following this actually fits into. Lithium, sodium, potassium. So you can see 39 plus 7 divided by 2. That is coming out to be 23. That is nothing but sodium, right? So that means these triads are valid in this case, right? Now let us talk about the other cases as well. Calcium, strontium and barium. This also 40 plus 137 divided, you will get 88.5. This is not exactly the same number, approximately the same number, right? Now here also 35.5 divided plus 127 divided by 2, you will get 81.25, and here it is 80. So this is also not the same. That means, can we say that exactly the same atomic mass you can't get, right? That is valid in lithium, sodium and potassium, but that will not be valid throughout all the elements, right? That's not possible. That is why these Daubernier triads were ruled out, because they had disadvantages. It was not applicable throughout, right? So that's why we have our second rule, that is Newland's law of octaves, right? That is called Newland's law of octaves. Now in Newland's law of octaves, what you will study here, that it's like sa re ga ma pa dha ni sa. Okay, sa re ga ma pa dha ni sa. Okay, so I'm not that good in music, right? So sa re ga ma pa dha ni sa. That means sa and sa, first and eighth element are the same, right? So what we can see, lithium, if you can see, this is the first element. This is the first element. Hydrogen, helium was not there. At that point, helium, noble gases were not invented, right? Hydrogen, lithium, 1, 2, sa, re, ga, ma, pa, dha, ni, sa. So hydrogen and fluorine. Then fluorine, sodium, sa, re, ga, ma, pa, dha, ni, sa. So that means hydrogen, fluorine and chlorine, they are having the same properties. This is what they are saying, right? Then they are saying the second element is, let's talk about this. Sa, re, ga, ma, pa, dha, ni, sa, right? So lithium, sodium and potassium, they have the same properties. After that, you have beryllium, magnesium and calcium have the same properties. Now, till here it is same. Till here, till calcium, it was verified. Till calcium, it was verified that it is having the same properties, right? But after that, we got confused. Why? Because here you have chromium, here you have aluminium, here you have boron. And if you know the modern periodic table, group number 13 is boron, aluminium, gallium, bal, gai, indium, thallium. There is no chromium here. Titanium is also a part of transition series. Manganese is also a part of transition. Iron is also part of transition. That means this thing is not valid after calcium for the elements that were known at that time, right? So that is why we can say that this particular law was also ruled out. Okay, this particular law was also ruled out. And what we can say here, arranged in increasing order of the atomic masses, every eighth element is similar, but limitation is it is only valid up to calcium, failed for heavier elements. Up the one that has more mass, it got failed for them, right? That's why this was also ruled out, right? Okay, then next one is Mendeleev, right? What is the next one? Next one is for Mendeleev periodic table. Now, anybody in the chat box, Mendeleev periodic table is based on which property, right? Mendeleev periodic table is based on the atomic masses. right? It is based on the atomic weights, it is based on the atomic masses. We can say the properties of elements in a period is the periodic function of atomic weights, atomic masses, not the atomic number. Till here, we have no idea that we can relate the properties with the atomic number. Till now, we are thinking about atomic masses, atomic masses, atomic masses only, right? Now, if you can see this here, right? This is the Mendeleev periodic table. Ma'am, do I have to go through this Mendeleev periodic table in detail? The questions are not usually asked on Mendeleev periodic table. More questions are asked based on modern periodic table. But you should know the drawbacks, the limitations, the advantages of Mendeleev periodic table, right? So this is zero. This particular group was not invented at the time of Mendeleev, right? When there was Mendeleev, noble gases means zero group was not there at the time of Mendeleev. You can see first, second, third, fourth, fifth, sixth, seventh, eighth. These all groups were there in the Mendeleev periodic table. And you know what exactly was there? Every single, you can see these groups were also divided into two parts. Okay, these were divided into two parts. Okay, so each group was divided into A and B, and the last eighth group was divided into three parts, right? But because this was based on the atomic masses, so we don't need to learn this, right? You just need to know some important points regarding the Mendeleev periodic table. I'll tell you what are those important points. So the important points are, it is based on the atomic weight. 63, only 60. See, right now we have around 118 elements. Only 63 elements were known at that point. Noble gases were not discovered. There was no group 0 in your NCERT. If you see in your NCERT, group 0 they have mentioned, but group 0 was not there at the time of Mendeleev, right? Then the horizontal rows are called periods, vertical columns are called groups, right? There were 7 periods and 8 groups. Each group up to 7th was divided into two parts, that is A for normal elements, B for the transition elements. So you can see for yourself that A group, this is the A group, this had normal, these are transition, transition, transition. So these are the transition elements in group B. Okay, that's how they were divided, right? Now the 8th group was divided into three parts, right? Okay, the 8th group was consisting of 9 elements in each row. There was in 3 rows, right? Transition metal groups it was. The elements belonging to same group exhibit similar properties. Now till here Mendeleev, Mendeleev told something about the properties also. Lothar Meyer also did the same thing, right? Lothar Meyer also did the same thing. Lothar Meyer plotted a graph. If you talk about Lothar Meyer, he plotted a graph here, right? He plotted a graph and he told that, okay, in this graph, right, same assumptions he took. He took about the descending peaks, the ascending peaks, everything same he told about as Mendeleev told, right? But the problem was that graph was very difficult to understand, and Mendeleev was first to submit his reports. That's why he got all the credits, right? So that's why you only not had to be, there should be smart work also along with the hard work, right? That we can see from the story of Lothar Meyer, right? So from the story of Lothar Meyer, it is clear that smart work is also very important, isn't it? So the advantages, you can see, what were the advantages? Study of elements. Now the advantages were the study first time all known elements were classified in groups according to their similar properties, right? It was the first time. Before that, we were talking about very few elements. We were talking about triads, we were talking about 7 set of elements, we were talking about 3 set of elements. Now we have put the elements in a groups. That means there is something new that we have done at that point, right? Prediction of new elements. Now, how he predicted the new elements? On the basis of the properties of the known elements, he predicted some new elements. What were these elements? Eka means the element that he predicted, right? Eka aluminium is nothing but gallium. Eka silicon is germanium. Eka boron is scandium. Eka manganese is technetium. Okay, so these are the elements that were found after the Mendeleev's periodic table, but that was the biggest discovery, that he discovered some elements, right? Discovered means he told that there will be some element that will be found in the future, and you can place this element over here. That was a very, like, it's a big discovery, right, by Mendeleev. So that's why this is very important. They can ask you question till now. If I talk about whatever I have talked about, this is the first question that they can ask you in the exam regarding what is Eka boron, that is scandium, what is Eka silicon, that is germanium, what is Eka manganese, what is Eka aluminium, right? Now, next is this is the data that is given in your NCERT as well. The data says that if you talk about Eka aluminium, this is gallium, this is Eka silicon, this is Eka germanium. Now what you will see, that what was predicted are 68, that we predicted that atomic weight will be 68. In reality, it is found out to be 70, which is approximately same. He predicted that the density will be 5.9, but in reality, it is coming out to be 5.94. So he predicted the properties also of those elements that were not discovered at that point, but he said that one time this element will be there in the future and these will be the properties, right? Okay, so that was a big deal. Okay, understood? That was a big deal. Now, next is there were some corrections also what he did. The corrections were done in the atomic weights of elements like uranium, like beryllium, indium, gold, platinum, right? So he did some corrections here in the atomic weights. Okay, how he did these corrections, that also I'll tell you with the help of this important formula, right? So this question they can ask you, this is a very important question. Okay, this question beta they can ask you directly based on this. The atomic weights of beryllium were corrected by Mendeleev using the formula. Which formula he used? Which formula he used? He used this formula. Atomic weight is equals to equivalent weight multiplied by valency. By this formula and doing the calculations, right, he calculated that the beryllium mass is incorrect, right? The beryllium mass, he corrected it, that this is the mass of beryllium. And what are the other masses that he corrected? Uranium, beryllium, indium, gold, platinum. All these masses he corrected by atomic weight. He firstly calculated the equivalent weight, right? Then he multiplied it with the valency factor. That's how we got the atomic weight of that element, right? Okay, understood? So answer will be C, right? Now, next is the drawbacks. Now, what were the drawbacks of Mendeleev periodic table? Drawbacks were some elements did not fit the table if atomic weight is strictly followed. Now, he said that if we follow the atomic weight, you know what will happen? Some element will not fit the table only, right? He himself, if let's say, if I talk about, light gone, guys, light gone. That's why I was not taking the class, right? Because I knew that today the weather is not good, so power cut might happen. But I really hope so. The UPS don't. I really hope so. UPS works. Okay, chalo. Now we have the properties of what exactly we noticed here. You can notice here some elements like in the atomic weight, so it was right. Okay, so I'll tell you here. What are these elements? There was chromium and nickel. Where is chromium and nickel? Right, this is chromium. Right, this is nickel. Right. Okay, 52, 54, 58. Wait a minute. Yes, it is here. You know, my heart started beating so fast. Chal. Now, what actually happened here? What is happening, guys? Okay. Some elements did not fit the table if the atomic weight is strictly followed. So what exactly happened? If you strictly follow the atomic weight, like iodine was placed after beryllium in the group 6 with fluorine, chlorine and bromine. So I'll just look for this. Iodine was placed after beryllium. Iodine after beryllium, right? This is the example that I was looking for. Where is fluorine, chlorine? Huh. Okay. Yes. Now, yes, this is the mistake. This is the mistake. So this is one of the mistakes. There are other mistakes as well in Mendeleev periodic table, right? You can, if you go through this in detail now, then you will get to know that where are these different mistakes. This is one of the mistakes, that this is beryllium, this is iodine. This is 128, this is 127. If you are filling this according to increasing atomic weights, it should be iodine here and beryllium here. But iodine, we all know that fluorine, chlorine, bromine, iodine, they all are halogens. This we know today, right? At that point, they were conducting experiments and they knew that fluorine, chlorine, bromine, iodine, they all have same properties, so they should be in the same group. So he forcefully put iodine here and beryllium here. So there was no logic behind that why you should have iodine here, because they have same properties, that's why you put it here. But then then Mendeleev himself was telling that this should be on the increasing order of atomic weights. So he is himself neglecting his own principle, right? So that was the biggest drawback of Mendeleev, right? That was the biggest drawback of Mendeleev. That's why it is not important for us, right? That's why we don't learn Mendeleev periodic table, right? Ignoring atomic weight placed elements with similar properties together, just as he placed it. Despite being in the same group, some of the elements did not have same properties. So some elements, they were, so what he did, sometimes he'll put forcefully some element in the same group, even though his own principle was altered, right? Sometimes he did not put the same properties elements in the same group, right, to follow the atomic weight. So it was very chaos in the Mendeleev periodic table. Position of hydrogen, though position of hydrogen is even now, it is not fixed. Even in modern periodic table, there is contradictory. The position of hydrogen is even now, right, 2025, it is still contradictory, right? So position of hydrogen was with group 1 elements, but certain properties resembled with hydrogen. So we know that it can gain 1 electron and become hydride. It can lose 1 electron and become proton, right? So both the things were there, right? So next is Mendeleev periodic table based on atomic mass did not talk about isotopes only. So we know what are isotopes. Isotopes are same element but different atomic masses. The element should be same, the atomic mass will be same. Just like you have carbon 14, you have carbon 13, you have carbon 12. These are having different neutrons. The mass is different here. So if you are saying that, if Mendeleev is saying that I am talking about different masses, then you should also give different position to the different isotopes. You should give different position to hydrogen 1, deuterium and tritium. But he has not done that. So that's why he ignored the existence of isotopes. Next is Mendeleev's could not explain the cause of periodicity among the elements, right? Why this periodicity is there, right? First thing is the periodicity was not at all right, right? So he is forcefully doing the things, right? Then when we talk about that, Mendeleev could not explain the cause of periodicity, right? So he could not explain that why he has taken atomic mass, right? Now what will happen? Now the base of modern periodic table will start. Now what is modern periodic table, right? Let us talk about modern periodic table. Modern periodic table was based on, this is a very important page, based on which questions are asked. From here, important part has started. Till now, everything was not so important, right? Because in previous time, not so many questions they are asking from those things, right? But from here, important part has started. That is, Henry Moseley observed regularities in the characteristics of X-ray spectra. Henry Moseley, what he observed that in physical properties and atomic number, there is some regularities, right? Regularity in the characteristics of X-ray spectra of the element, he observed that mu, frequency versus atomic number, gave a straight line. Now, the question that they can ask you is, Henry Moseley draw a graph between which of the two things? Mu versus which thing? Under root mu versus atomic number. It is not mu, it is under root of mu. Okay, so he took the under root of frequency versus atomic number. He got a straight line graph. Straight line graph means as the atomic number is increasing, mu is also increasing. So that means if one physical property is directly proportional, others will also be directly proportional. So now what he observed, that this also I have written, not mu versus atomic weight. Atomic weight he was not talking about. He was talking about atomic number, right? He thereby showed that the atomic number is more fundamental property of an element than the atomic mass. Atomic number is the fundamental property, not the atomic mass. Until now, our full modern periodic table is based on this particular property, right? That's why this Henry Moseley question is very important, and this particular experiment plays a very important role. So that's why under root mu versus atomic number, that's how he got to know that fundamental property is atomic number, not the atomic mass, right? Now the foundation of modern periodic table will start. The physical and chemical properties of elements are periodic function of their atomic numbers, not their atomic masses. Next is periodic repetition. Now, why? Now, it's like, why, ma'am, there is repetition? So, he also gave the answer for that. Periodic repetition due to similar valence shell. For atomic weight, if you remember, we wrote that in Mendeleev periodic table, he was not able to explain that why there is regularities because of atomic weights. But this law explained it, that why there is proper periodicity. He said that when you go down the group, okay, we are talking about one single group, right? Now he said that the outer valence configuration is same. The valence shell electronic configuration after certain regular interval is same. That means if I talk about group number 1, that has NS1 kind of electronic configuration, group number 2 has NS2, group number 13 has NS2 NP3, group number 14 has NS2 NP4. These kind of electronic configurations, this will not be NP3, this will be NP1. Group number 14 will be NS2, NP2. Group number 15 will be NS2, NP3, right? And then 16 is NS2, NP4, 17 is NS2, NP5, 18 is NS2, NP6. Okay, so that means throughout that group, right, all the elements will have same outermost electronic configuration. That is the reason the repetition in the properties was there. Okay, the periodicity in the properties was there. Now this is your modern periodic table. Can you see this? This is your modern periodic table that we were talking about. Now this periodic, to understand chemistry, this periodic table should be on your tips, right? This periodic table is very important and this should be on your tips. You will understand that how it can be on your tips. Okay, students? Now you let me know in the chat box. You will let me know, guys, in the chat box, how many of you have actually, learned the periodic table. I want to know this very seriously. If you don't know, then do let me know. I also saw a meme on this. I don't know how many of you understand Hindi. I saw there is a song in Hindi. There is a song in Hindi. So I saw a meme recently. I don't know, students right now are so creative. So creative. Me, ma'am, me. What if ma'am knows Telugu? I do understand that. 118 element learned. Very good, very good. So have you heard that song? What was that? मेरे कमरे में फोटो तेरी मैंने नोच नोच के फाड़ दी. याद है? Do you remember that? मेरे कमरे में, you can just talk to your periodic table like that. मेरे कमरे में फोटो तेरी मैंने नोच नोच के फाड़ दी. Isn't it? Yes, ma'am. We hate periodic table, ma'am. Why we have to learn this, ma'am? That should be given in the. How many of you agree that that should be given in the exam, ma'am? Why they don't give calculator, ma'am? Why they don't give my periodic table, ma'am? What's the use of making us cram all these things? Isn't it? I used to think about that. What intelligence they are checking by knowing that how fast calculator am I? How fast I can learn. But now I understand that why it was there. You know, when I talk to my classmates who are there right now doing PhDs also outside, like abroad, they tell me that in reality, Indian education system is tough as compared to abroad education system. And that's why you will see that Indian brains, right? You know, because our brain are trained that way that we can even do like tough calculations by itself, right? So we have the capability of memorizing things. So it's not that they are checking your memorizing power, it's just that they want to check in the exam that if a student has learned something, is that student able to retrieve that information when that person is in the panic mode in the exam, right? So basically they are checking that how you handle tough situations, right? That is the thing that they are checking. You know, this is the same question that was there in my mind when I was a student, that why I have to learn this. I used to hate this. But right now, when I see that what is the benefit, then I feel that yes, little bit changes we definitely need, right? But I think we have one of the best books and we have one of the best content, right? That's why we have all over abroad, we have our doctors, engineers, right? So that is the reason our school education system is really good, but definitely some limitations are there. That would I would definitely agree, right? So this is the modern periodic table. What should be on your tips? First is group wise, it should be on your tips, right? Group wise means this group wise thing should be on your tips, right? Okay. Group wise means down the group, right? Group number 13, 14, 15, 16, 17, 18, right? Group number 1, group number 2, that should be on your tips. Along the period should also be on your tips, right? So I'll tell you today, mostly in periodic classification, we will talk about along the period, right? Down the group, you can learn this in P block as well when we will do P block, right? Now what you can understand, firstly let us understand some important things about the periodic table. First is it has 18 vertical columns. Vertical column means these things. It has 18. This is 10. This is 10. It's 2. Wait a minute. This is 10. It's 2. And this is 6. So you can see total you have 18 vertical columns. And how many horizontal rows? 1, 2, 3, 4, 5, 6, 7. Right? This is not the horizontal rows. This is the F block. This is S block. These two things, these two boxes are S block. This particular thing is the D block. This is the D block. This is the P block. Okay, this is the P block. So this is S block, this is D block, this is P block, and this thing is your F block. Now what you have to understand here, in the F block here, this F block is not different. You can't say this is 7, ma'am, this is 8, this is 9. No, this F block has, it has been taken out from this and this place. That means after lengthenum, you have lengthenoids. After actinium, you have actinoids. This is lanthanum, this is lanthanoids, this is actinoids. So after lanthanum, you have lanthanoids. After actinium, you have actinoids. Okay? After actinium, you have actinoids. Now, when you talk about the groups, okay? So when you talk about arranged elements in order of increasing atomic number, groups are the 18 vertical columns are called the groups. Each group consists of number of elements having the same electronic configuration of the valence shell, right? So you have group number up to 1, 2, 3, 4, 5, 6, 7, 9, and up to 18 you have. So I can also write down the group number for you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. Right? So these are the groups. Now what you will see in the groups here, what you will see that these groups 1 to 13 to 18, these group wise are very important for you. Now the outermost electronic configuration, you will see that this hole is S block, this hole is D block. I'll just write it here, right? And this hole is P block. This thing is P block. I'll just write it here, right? What you will see here, that the outermost valence electronic configuration will be same. That means this will be NS1, this will be NS2, this will be NS2, NP1, NS2, NP2. Like this it is going to be, right? Now, ma'am, I didn't understand. So for that, you have to go through in detail, right? All the electronic configuration, everything, we'll talk about that thing only now, right? So first thing, what is the characteristics? Okay, just give me some time, like in 10-15 minutes, you will get to know more about this. Periods. The table consists of 7 horizontal rows, right? Horizontal rows means these are the periods. You have 7 horizontal rows here. 7 horizontal rows you have. So I'll just copy paste this thing here. I'll just copy paste this thing here, right? I'll just copy paste this thing here, right? Isn't it? Now, what I'll give you here. So you have this thing. This is 1, this is 2, 3, 4, 5, 6, 7. One electron will be added as you go along the periods, right? Okay, so one electron will be added. These periods numbered as 1, 2, 3, 4, 7 up to top to bottom. The period number correspond to the highest principal quantum number. This is a very, very important statement, right? Okay. So let's say you have an atom, its electronic configuration is 1s2, 2s2, 1s2, 2s2, 2p6, 3s1. Can you tell me to which period it is belonging? Anybody in the chat box, to which period it is belonging? To which period? Anybody? The highest principal quantum number. What is principal quantum number? These are the principal. The number that is mentioned here is the principal quantum number. Okay. The highest principal quantum number, those who don't have any idea about principal quantum number, that is there in structure of atom. Okay, we will learn about that in structure of atom. So highest number is 3, so it will belong to the third period. Okay, it will belong to the third period. Okay, so that's how from the electronic configuration you can tell the period here, right? Okay, next is the characteristics of periodic table. Each period starts with an alkali metal having outermost electronic configuration NS1. Each period. And each period ends with the noble gases which has the outermost electronic configuration NS2 NP6. Right? How? You can see it here. Right? So all these periods, let's talk about any period. So all these periods, this is period 1, 2, 3, 4, 5, 6, 7. All of them has NS1. So all of them, any period you talk about, that will start from the alkali metal. This is alkali metal. This group number 2 is alkaline earth metals. Okay. Group 1 is alkali metals. Why I am telling you about S block more? See, S block is more important for you to understand in periodic classification, because P block eventually you are going to talk about in P block, right? D and F block also you have a different chapter for that. Okay, so that's why I will focus less on D and F block and P block. I will focus on S block, and period wise I'll focus more, right? Okay, so now if you talk about this thing here, right? If you talk about this thing here, this is NS1, and the NS, this is NS2, NP1, NP2, NP3, NP4, NP5, and this will be NS2, NP6. These are all the noble gases: helium, neon, argon, krypton, xenon, radon. All these are the noble gases. Noble gases means we know that from chemical bonding, right? So you will see that, ma'am, you're talking about different chapters, because see, it's chemistry, everything is interrelated, right? So in chemical bonding, you will study about the octet rule. Octet rule means every element wants to have the 8 electron in its outermost shell. So this is the outermost shell. It has 8 electrons, 6 plus 2. That is why it is stable and it will not react. That is why these are also called inert gases. Inert means, you know who is a noble person? Noble person, Sant, Mahatma. Who is that Sant? That saint. Saint. That is who do not react with anyone. Like, I can see you guys, you are reacting with each other too much. You are chit-chatting with each other too much. So you are not noble gases, right? You are reacting. You are highly reactive species, right? Okay. So now we will talk about S block elements, that is group number 1 and group number 2. The elements in which the shells up to n-1 are completely filled, and the last electron enters the S orbital of the nth shell. Right? What, ma'am? What he is saying, ma'am? Right? They are saying the element in which the shell up to n-1 completely filled, and the last electron enters the S orbital of the outermost shell, that is N. That means the last electron will be in the NS1. That is your S block. Okay? So either it can have NS1 or it can have NS2. Right? Now, ma'am, why NS3 is not possible? Answer is in structure of atom. Because we know that in S orbital you have only one orbital. That is why only 2 electrons can be filled here. In P you have 3 orbitals, 6 electrons can be filled here. In D you have 5 orbitals, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons can be filled. In F you have 7 orbitals. How many electrons, students? Tell me, beta. In S orbital we are saying 2 electrons are filled. In P we are saying 6 electrons. In D we are saying 10 electrons. How many electrons can be filled in F? How many electrons can be filled in F? Everybody, how many electrons can be filled in F orbital? Yes, how many electrons? How many electrons can be filled in F orbital? Right? I'm waiting for your answers. Right? So here, you will have NS1 or NS2, last electron. Ma'am, what do they mean by, ma'am, this thing? What do they mean by, ma'am, n-1 orbital is filled here? See, before S na, what exactly is the electronic configuration? If you see the electronic configuration, I'll just write it here. I'll just write the electronic configuration. Do you know how to write electronic configuration? SPDF, right? So SPDF is like this. This is S, 2 times you have to write. 2 times S, 2 times PS, 2 times DPS, 2 times FDPS. Can you see this here? It will start from 1, then 2, then 3, then 4. So 1, 2, 3, 4, right? 5, 6, 7, 8, right? Then P will start from 2. 2, 3, 4, 5, 6, 7. Now students will say, ma'am, you told that you don't need anything for this chapter. Beta, if you remember, those students who were there in the class before also, Tell me those students who have actually attended my basics lecture that I have taken 3 lectures from basics, right? Those 3 lectures that I took, I taught you this thing there because I know these things will be useful in every single chapter, right? So I have not taught you full chapters anywhere for 2026, but I have taught you 3 lectures. One is physical, one is organic, one is inorganic, where I have just picked up the basics, right? So that's why it is important, right? Then 3D, it is 3, this is 4, this is 5, this is 6. F will start from this side, 4, then it is 5. Now, beta, can you see one thing? Can you see one thing? Before 1S, there is no D. Before 2S, there is no D. Before 3S also, there is no D. 3S also, there is no D. But before 4S, also, there is no D. Right? Before 5S, what you will see? Okay? What they are telling you here, in which n minus 1 are completely filled. N minus 1 means, if we are talking about this 3S, this n minus 1, this is will be n minus 1, this will be n minus 1, this will be n minus 2, right? So these should be completely filled, okay? So if I talk about anything, let's talk about which one, ma'am? You tell me, which one should I talk about? You tell me which one should I talk about? Let's talk about, ma'am, 6S. Now, when I say that this element is belonging to 6th period, then what should happen? This is 2, 2, 6, 2, 6, 2, 10, then 6, then 2, then 10, then 6. After that, the first electron, that will be in the group 1. The second, if you have 2 electrons, that will be in the group 2. If n minus 1, and before that, all the orbitals are completely filled, and that last electron is in this s orbital, then we can say it is belonging to s block, right? Yes, very good, very good, very good, very good. Okay. Now, next is general electronic configuration is ns1 or 2. Either it can be ns1 or it can be ns2. Element of group 1 and 2 constitutes s block. Element of group 1 and 2, that will be in the s block only. Very good, you already have answered, that is F has 14 electrons, right? Very good. Now, students, let us talk about the next thing. That is, S block elements lie on the extreme left of periodic table. This was your periodic table. It lied on the extreme left, right? This block includes metals. All the elements here. Hydrogen is controversial, right? Hydrogen is not a metal. It is controversial, except for hydrogen. Lithium, sodium, potassium, rubidium, cesium, beryllium, magnesium, calcium, strontium, barium, all these are metals, okay? All these are metals. These are called alkali metals. These are called alkaline earth metals. This block includes the total number of elements including hydrogen. So, what you will see in most of the periodic tables, right? In some books, you can also see periodic table. In some books, what you will see, if I would say in some really good books, okay, you will see hydrogen here, right? Because they think that they actually take this controversy very seriously. Otherwise, usually you will see hydrogen here only, right? Okay. So you have to follow NCERT. In NCERT, hydrogen is there only, okay? So next is, okay, this we have done, this we have done, P block it is, okay. Total number of electrons are 13 here. Right, next, the P block elements. P block is group number 13, 14, 15, 16, 17, 18. These are P block elements, right? So in P block, the element in which shells up to n minus 1 are completely filled and the differentiating electrons enter in P block of the nth orbital. That means they are saying that this was the electronic configuration order, right? If the electron, let's say, enters, let's say here you have 6s, okay? Here you have 6s, right? The last electron has entered here. That means all the n minus 1 orbitals are completely filled. Before that, if you have, let's say, 5p, N minus means 4D, 4S. 4S is completely filled, 4DP is completely filled, 4D is completely filled. After that, when it enters here, that will be group number 13. If it enters, it is P2, it will be group number 14. If it enters P3, it will be group number 15. P4 means it is group number 16. P5, beta, tell me if it has group, if it has 5P5, which group it will be belonging to? If it has 5P5, if it has P5, which group it will be belonging to out of group number 13? See, the outermost electron is in, wait a minute, the outermost electron is in the P group, P orbital, that means it is belonging to P block. So that means it can belong to group number 13 to 18. Now tell me, it is 5 electrons, so which it will be belonging to? Group number 15. Wait a minute, not 15, it has NP5, na, group number 17. Okay, it will be belonging to group number 17. Okay, don't worry, I'll tell you the important trick about this also, right? Okay, then you have general electronic configuration is inert gas NS2 NP 1 to 6. It can have NP, NP1, NP2, NP3, NP4, NP5, NP6, right? Except for helium 1s2. Basically, this you can ignore here, because here they are talking about the noble gases, that all the elements in the group P block are, we can say, are having like the last electron in P. But here what you will see, helium has 1s2 electronic configuration, right? Okay, that's why hydrogen and helium are different, right? Hydrogen and helium are different. Elements of group 13 to 18 consist of P block. P block elements lie in extreme right of the periodic table. They will lie over here. This block includes some metals, all non-metals and metalloids. It will have metals as well, non-metals as well, metalloids as well. The total number of elements are 37 here, right? So it will have metalloids. So this beta, they can ask you which of the following are metalloid. Boron, silicon, germanium, arsenic, antimony, beryllium, all these are the metalloids, okay? And all these are non-metals: carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, selenium, boron, iodine, all these are non-metals. And what are metals? Boron, this aluminium, gallium, these are specially metals, okay? So it will have metals, metalloids, non-metal. That is why this P block is specially studied. That you will study, don't worry. Then there is D block. D block also you have a chapter, DNF block. We will study this in detail in DNF block, right? So this is basically in D block you will study about 3D series. Okay, this is the 3D series that we are going to study about. But this is 4D series, this is 5D series, this is 6D series, right? Okay, and what is the group? This is group number 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? You should know along the period and down the group as well, the electronic configurations, the atomic numbers, the pattern here, right? 3D series is very, very important, right? This 3D series, you can mark it. It's very, very important when you will start studying class 12th, right? When you will study class 12th, this 3D series, the mnemonic should be on your tips, right? That should be on your tips. Okay, students. Now, let's talk about D block elements. So, D block elements are interesting. The elements in which outermost nth and the penultimate. What is penultimate? N minus 1 shell. Now, till now in S block, we were saying that the outermost electron should be in the highest highest principal quantum number, that is highest value of n, right? Now we are talking about the outermost electron will be on the n minus 1 d, okay, n minus 1 d, right? So here you can see are incompletely filled and the differentiating electron enters in n minus 1 d orbital. right? Elements are from 3 to 18. General electronic configuration are N minus 1, D, 1 to 10. And you know, this is very important. N minus 1, this is N minus 1 is called penultimate shell. N minus 2 is called anti-penultimate shell. Okay. So N minus 1, you will have from 1 to 10, you can have electron 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, depending upon the atom. Why I am not generalizing this? Because there are so many exceptions in the electronic configuration of 3D series as well. Chromium, copper, these are the exceptions, right? So, except palladium. So, now palladium, why it is so? See, usually s orbital will have either 1 or 2 electronic configuration. But palladium is the only atom, which will have 5 is 0. That means even in the s orbital, it will have 0. It is the only element in the d block which has 0 electron in s orbital, right? Okay, which has 0 electron in the s orbital. That is why the electronic configuration of PD becomes very, very important, right? Okay, understood? Now, the elements which have partially filled d orbitals in the neutral state or any stable oxidation state are called the transition elements, right? They are called the transition elements. All the transition elements are metals and most of them formed color compounds. Now, a D block, you will study this in details. They are very famous for colored compounds. You have coordination chemistry, that is C. If you study this chapter, you will find it very easy to study DNF block. And after that, coordination chemistry, these two are of class 12th. These two chapters are entirely based, this chapter is entirely based on D block, right? So, if you study transition elements in detail, then only you will be able to understand coordination complexes, right? So, this is what they are saying. They form colored complexes. They are called transition elements. Why transition? Transition elements are those elements which don't have fully filled d orbital, right? Okay, so you can say partially filled d orbital. That is why zinc, cadmium and mercury, right, these are non-transition elements. These are called non-transition elements because what will happen in the excited state and even in the ground state, they have the fully filled d orbital, right? So that is not needed, right? Total number of electrons, total number of elements are 40 here, right? Then you can see D block elements are classified in 4 series here. You can see it here, first transition series 3D, then 4D, then 5D, then 6D. From scandium to zinc, from these are see. Wait a minute, let me just show you that thing here. This I forgot to told you. From this lanthanum, what you will see, 4 lanthanoids will start. Here you will have 4F series. Here you will have 4F and here you will have 5F. So instead of writing it here, we have a different block for 4F and 5F series, that is lanthanoids and actinoids, right? Okay, but in reality, lanthanoids and actinoids are belonging to group number. Lanthanoids and actinoids, beta, they belong to which group? Anybody? Lanthanoids and actinoids, they belong to group number 3. That is this group. Okay, lanthanoids and actinoids will belong to this group only. What students saying that they have a different group, ma'am? No, lanthanoids, actinoids don't have a different group. They are inner transition elements. F block elements are inner transition element. This is the transition element. In between the transition element, you have lanthanoids. So lanthanoids and actinoids don't have a different group. They belong to group number 3 only, right? Okay, all the lanthanoids, all the actinoids, they belong to group number 3 only. Now, very important thing, right? Very important thing that, chalo, let's talk about F block, then I'll talk about that thing, right? So, when you talk about F block here, this is 4F series that I talked to. This is 5F. They both belong to group number 3 only, right? But if you talk about lanthanum, So this is the confusion, you know, even if you're in 12th class, you might think about this for some time. Lenthanum belongs to which period? Okay, you tell me lenthanum belongs to D block or F block? Lenthanum belongs to D block or F block? Anybody in the chat box? Anybody who can answer me that? Lenthanum belongs to which group? D block or F block? D block or F block? Yes, students, lenthanum belongs to D block or F block. I'm waiting for your answers, right? I am waiting for your answers, students. Okay, Aura is saying D block. Vijnesh is saying D block. Shraddha is saying D block. Ibu is saying D block, ma'am. Okay, Gopika is in some another world only. Nitika is saying D but F. D but F, playing safe, huh, Nitika? Okay, D I think. Very good. Lenthanum belongs to D block. Beta, lenthanum belongs to D block, but lanthanoids belongs to F block. Lanthanum belongs to D block, but the lanthanoids, they belong to F block. Similarly, actinoid, this actinium belongs to D block, but all the actinoids, okay? What are lanthanoids? Interesting part is, in lanthanoids, you don't have lanthanum. Lanthanum is not a part of lanthanoids. Actinium is not a part of actinoids, right? So this is where students might get confused. Lanthanum is not a part of lanthanoids. Actinium is not a part of actinoids, right? That is a part of D block, right? The lanthanoids will start from cerium, right? And the actinoids will start from thorium, right? Understood? Lanthanoids, actinoids. These are inner transition elements. Now, as I told you, in D block, you have a penultimate shell that is filled, that is the outermost orbital. And in F block, you have anti-penultimate shell, that is the outermost orbital. So you can see the elements in which n, n-1, n-2 shell are incompletely filled, and the last electron enters the F orbital of anti-penultimate. That means the last electron here, what you will have ns2 completely filled. In D orbital, either 1 electron or 2 or 0 electron you will have, right? In the penultimate shell, either 1 or 0. Now you will say, ma'am, why 1 or 0? Beta, that's not in my hands, right? That's how the electronic configuration is done. Okay, so there were exceptions also. This is experimental data, right? So either 0 or 1 electron in D block, that is penultimate. In anti-penultimate, that is n-2 F orbital, 1, 2, 3, 4, like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, maximum 14 electrons can be there, right? Okay. Okay, Ji. And right now they are asking questions. Why I'm focusing on like lanthanoids so much? Because they are asking questions on the electronic configuration of lanthanoids that you will study in DNF block. Okay. So let's talk about the next thing. They are also called inner transition elements as they contains outermost shell is incomplete, right? They are also rare earth metals, right? Since their oxides were rare in earlier days. So at that time, it was called as rare earth metals. Very rarely they were there, right? So now let us talk about the last one, that is the noble gases. Okay, so these are the noble gases, are sant, are saints, right? Who are like, I'll stay single, right? I don't have like any emotional attachment with the world. It's not like I'll see an electron, I'll try to gain the electron, I would want to lose the electron. So they are very stable, they are very happy. Now what here you can see? Can you see one pattern here? This is 2, you add plus 8, you will have 10. You add plus 8, you will have 18. You add plus 8, you will, You add plus 18, you will have 36. You add plus 18, you will have 54. Plus 32, 86, plus 32, 118. So, you know what you will observe here? You know what you will observe? that 8, 8, 18, 18, 32, 32, these are the magic numbers. These are the magic numbers. Magic number means if you want to, in the same group, you want to identify the next element, you have to add the magic number. Okay, so I'll tell you how. Okay, I'll tell you how. Chalo, we'll see it from here only. Magic numbers, knowing the atomic number of the first member of the group, we can write the atomic number of the subsequent elements of by adding the magic numbers, right? So how we can do that? So let's take an example. Here it is. Yes. Okay. So this is the example. Let's say we are talking about atomic number 1. Atomic number of hydrogen is 1. Atomic number of other elements will be as follows, right? Magic number is 2, 8, 8, 18, 18, 32, 32. That is the magic number. Okay. So when you add 2 here, you will have 3. That is for lithium. For lithium, when you add 8, you will have 11. That is for sodium, right? Okay. Then you add 18, you will have nitrogen. Then you will have, you will have 19, that is potassium. Then you add 18 here, you will have 37 rubidium, and this will be cesium, right? So what you did here, you added 2, 8, 8, 18, 18. This is what you added, right? This is what you added here. That's how you got the full-fledged number. Okay, so these are the magic numbers that will give you full answer for that. Okay, that will give you full answer for that, right? Okay, understood? Yes, everybody. Now let us talk about the periodic table. So everybody, now just pick up your pens and let's draw the periodic table. I hope so you remember that. Okay, let's draw the periodic table. Let's draw it now. What's the big deal? 2, 8, 8, 18, 18, 32. Very good. Very good, very good, very good, Akash. Very good, Aura. Very good. Now you will be like, bro, what you are saying? Acha, tell me, what is this BR? What is this BR? What is this BR? This is a symbol of which thing? Now I want you guys, I'll not give you one as a good fun quiz in the comment section. I'll ask you, I'll give you some sentence. You have to tell me that sentence can be framed from which elements, right? Okay, you have to tell me that sentence can be framed from which elements, right? Okay, just give me a second. Just give me a second, hai na? A very interesting thing here. Ma'am, what you are searching? Wait. अरे यार. Chalo. Some other day. Right now, I don't remember that. Some other day we'll do that. Okay. So this Br is bromine. Okay. What is this U? Uranium. Then what is this H? Hydrogen. Right. Okay. So okay, I'll just give you one thing here. If you want to write I love you, then how you will write that? Okay. I have seen that meme somewhere, but I forgot that what was exactly there. I think that was IL. I don't remember that. I'll search for that thing and I'll just, because that was a very interesting thing, right? So that was nice and very interesting. Chalo. Now let's draw the periodic table here. Prediction of period, group and block here, that we will predict, right? Chalo. Firstly, what we need to do? Firstly, we need to learn the mnemonics, students, right? If you don't remember the mnemonics, then how you will answer that, right? So firstly, we will try to learn the mnemonics. QT. QT to I know. Science like ma'am, QT I remember. Copper sterilium, yeah. So I can write it there because these are some very, very interesting things that I personally really like about CTCUT. That is copper beryllium. When you want to write cute, chemistry students don't write cute, CUTE. Right? Chemistry students write copper, you are copper plus beryllium. The other person will be like, what? You will be like, cute, yaar, you are very cute. Ma'am, I made one. Acha, tell me. What you made? Let us see. Let us see what you made. So let us see from the periodic table only. Let's play this fun game here. Okay, I'll just see. You will also get relaxed in between the class. Okay, where was the periodic table? LV, LV, LV. This is LU. This is V. This is I. Right? Next time you want to tell your mother, yeah, your mother. You want to tell your mother that I love you. Right? To your mother. Right? Not to someone else. Right? So next time you want to tell your mother, I love you. I love. Where is you? Where is uranium? Where is uranium? This is uranium. So you will not say I love you. You will say iodine, iodine. Then you have lutetium. Then you have vanadium. Then you have uranium. Right? This is how you tell someone secretly that I love you. So I always tell my students, I love you guys. So next time I'll not tell I love you. What I'll tell you, I'll say iodine, lutetium, vanadium, uranium. Right? Those students who actually love Diksha mam also, they will only able to understand. Those students who don't love Diksha mam, who are like, okay, sometimes they only watch my lectures, they won't be able to understand what ma'am is saying, iodine, lutetium, vanadium, uranium. Isn't it? Okay. So how you tell I love you? Everybody, how you tell I love you from the next time? Students say, ma'am, you are cute. No, I am not cute. I am copper and beryllium. Isn't it? That's how to propose a chemistry, like chemistry file kind of person. Ma'am, you must be oxygen because I can't live without you in my system. Oh my God. Oh my God. Omega. बेटा ऐसा क्लीशे लाइन नहीं मारनी. Then you can say, you can, tease Namrata ma'am like that. Isn't it? Chalo, you can tease Namrata ma'am like that. Iodine, lutetium, vanadium, then uranium. Okay, now let us see the mnemonics. Over with the fun part. Okay guys, over with the fun part. Only sometimes I do the fun part in between the class. Usually you will see my classes are very, very serious, right? But I feel that, okay, you guys also need some relaxation in between the class, right? Chemistry is fun, so let's make it fun only. So these are the mnemonics. See, I can't do anything with the mnemonics. So these are the mnemonics for group number. This is period number 1. You can see the mnemonics here, right? This is for period number 2. You can see hydrogen, helium, lithium, beryllium. Hydrogen, helium, lithium, beryllium. Wait a minute. I think there is some beryllium. This is not the correct mnemonic. I'll just delete this here, right? This you can remember, right? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So what I'll do here, wait a minute, what I'll do here, right? Chalo. Right? So you should remember period number 1, right? Wait a minute. Buck, no, funny. Oh, yeah. This is not right. I think by mistake it got added. Period number 3. Wait a minute. I'll just show you that periodic table only, right? What you have to remember, right? Okay. First thing is, beta, you should remember this thing, right? You should remember this thing here. That was lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Then up to argon and up to this thing, so you should remember up to 1 to 20 should be on your tips. Okay, 1 to 20 should be on your tips. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. Okay, so first 1 to 20 elements should be on your tips. Okay, they should be on your tips. Then what you should remember is group number 1, that can be Lee, Na, Ki, Ruby, Say, Friendship, Beta, Mange, Car, Scooter, Baap, Razi. Then here you can remember बाल गए इंडियन तेल, काशी गए संत प्रभु, ना पी ऐसी शराब भाई, उससे टेपो, फ्लोरीन, क्लोरीन, ब्रोमीन, आयोडीन, then हीना, नीना और कैटरीना, xenon, radon. Okay, so that's how you should remember all these groups and elements. Okay, so that's how you should remember all these groups here, beta. That is very, very important for you, right? And those students who don't remember, right, this I will, wait a minute. This is, wait a minute, I'll just write it here only. I don't know where it is now, yaar. I can't find it. Chal. So this is your P block. Okay. Now that I told you that how to remember 1 to 20 you should remember. Then serial wise you should remember 1 to 20. Group wise you should remember group 1, group 2, group 13 to 40. Now in P block, how to remember period 2? Period 2 will be along the period. I am not talking, one is down the group. It is Baal Gaye Indian Tel, right? But along the period, it is Buck No Funny. Or you can remember Buck No Funny, right? I remember this by Buck No Funny. You can also remember bake cookies, not Oreos, not Oreos for neighbors, right? Bake cookies, not Oreos for neighbors. Then period number 3, aluminium, silicon, phosphorus, sulfur, chlorine, argon. That is in period number 3, right? For that, you can remember always signal people silently clowning around, right? Always signal people silently clowning around. Then for the period number 4, gallium, germanium, arsenic, selenium, then boron, then krypton. This you can remember by gabbling geese, asteroids, several Brisbane kangaroos. Okay, so it's totally your choice. If you have like from normal also, you can remember this, right? Then there is indium, tin, antimony, beryllium, iodine, xenon. How you can remember this? Infectious sniffles, sub-site testing, iodic xenophobes, right? Okay, so that's how you can remember this. Now there is 3D series, right? Then there is 3D series. How I remember this is Saktiv, Karman, Fico, Nicojan. Say, I would advise you why I have given the mnemonics, that is in English. So if you're comfortable in English, you have very good vocab of English, then only go for these mnemonics. It's not important. Ma'am can't see it because of brightness. Arey, is it? Chalo, don't worry. You just understand what I am telling you. This you can, I'll provide you with the PDF. Okay. So How I remember this is Sakti, V, Kar, Man, Fi, Ko, Ni, Ku, Jan. Okay, that's how I remember the 3D series, right? So you can make your own mnemonics also on this 3D series. Then there is mnemonic for 4D series. 4D series is Y and Z are two friends, say number teacher R square and party RD to a CD, right? So that's totally your choice what you want to remember, right? I have my own way, you will have your own way. You can also alter these mnemonics. You can just neglect these mnemonics and you can make your own mnemonics. I would advise you make your own mnemonics in your own regional language, right? In your region, because we are most comfortable in our regional language. So that's why I don't focus that much on mnemonics and I hardly ask my students to follow my mnemonics. Reason being, see, your life is different. Your own comfortable zone, comfortable language is different. Okay. We all know English is not that comfortable to us, right? So that's why I will advise you learn this in your own regional language so that you can and relate that to your own life. Okay. Try to relate the mnemonics to your life. Like here you have 5D series. Hi, Hafnia. Did you know that iridium got a bad itch after eating marigold platinum biscuits? Right? Okay. So that's how you can learn 5D series in your English, right? Then the last one is for F block. So this is full for F block. You can go through that. Okay. This is for F block and like 4F and 5F series, right? Okay. Now let's talk about how to identify the groups. Prediction of period, group and block. Okay. Now let's talk about period, group and block. And I would really want you guys, let's say your regional language, you can mention your regional language because I know that my students are from different parts of the country, right? So your language can be different. So I would advise you to write in your own regional language or in English or in Hindi or in Telugu, which language you are comfortable in. You have some mnemonic, write it down in the comment section, right? Any mnemonic. If you have mnemonic for all of these, you can write it down so that other students also get benefited from that, right? Okay. Yes, everybody. Ma'am, I mix all languages. Everyone has their own style. This is how I do, right? I will also mix Hindi, English, mix, right? Then I'll make some mnemonic. That's why my mnemonics are very different from yours. I remember things by Bal, Isse, Tepo, right? Then I remember by Hina, Nina, right? These are the mnemonics that our teachers taught us and that is there in my mind, right? Even if I try to learn new mnemonics, I won't be able to do that, right? Because in my head from last 20 years, it is there in my head that it has to be like that, right? Not 20 years, let's last 15 years, right? Yes. So period, block and group. So now we will understand that what is period, what is block, what is group. So if you talk about period, along the period, block, which block it is SPDF, group is which group it is belonging to. So if you talk about, this is a very simple thing that whenever they are asking you regarding the periods, right? If you want to answer period, period will be a highest n value. Highest n value is going to be period. Block will be last electron in which n. In which principal quantum number you have the last electron, that will be your block. Okay. So for S block elements, group number is number of valence electrons. For P block elements, you can say group number is 10 plus number of valence electron. And you can say for D block elements, group number is number of electrons plus number of electrons in valence shell. So what do you mean by that? I can just directly write for S block elements, just write the number of electrons in S block. Valence shell means S block in S electrons, right? For P block, it will be 10 plus number of electrons in P block. p electrons, outermost p electrons. D it will be, D you can just write it here, D is going to be 12, or you can see 2 plus number of D electrons. 2 plus D electrons. Okay? Yes. S is, P is 2, then it is D. Yes. Okay? Understood everybody? Understood? Right? Any problem? You know, in chalo theek hai, that is it. Okay. Now let us talk about how to answer this. If an element M has atomic number 51, what is the group and the period? See, first you have to write the electronic configuration here. So once you write the electronic configuration here, right? Firstly, I would want to write the electronic configuration only. So I would like to write the electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p6, right? You can just copy paste that thing here, right? We already wrote the electronic configuration, right? So what we can do here is, okay, so what we can do here is, I can just write down the electronic configuration here, right? I can just write down the electronic configuration here, right? So that will be 2, 2, this will be 10, 2, 12 plus 16, that will be 18, 19, 20, 20 plus 10, 30, 36, okay? 36, then there is 38, then there is plus 10, 48, then it will be 48, 48. 51 minus 48, it is going to be 3. So you will have 48, 49, 50, 51. That means the last electron will be here. That means, beta, can I say this will be the last electron here? Can I say, students, this will be the last electron here? This is going to be the last electron here. Can I say that? Can I write that? Yes, students, can I write that? Isn't it? So I can say that 2, 2, 2, this will be the last electron here. So when we are writing the last electron here, now can you predict the period here? Which is the largest value of n? What is the largest value of n? Tell me, beta, what is the largest value of n? 1, 2, 3, 4, 5. Largest value is 5. We are not saying which in which principal quantum number the last electron is. I am asking you which is the largest value. Largest value is 5. So answer will be period is 5. Block. The last electron is in p block. So block will be p. Okay. And what is the group? In p block, you add 12 electrons, right? 12 plus how many electrons here? 3. So it will be 12, 13, 14, 15. So it will belong to group number 15. Okay, it will belong to group number 15. This is what you will see here. Okay, this is what you will see here as well. Group number 15, period 5. Okay, that's how to answer the period, the block and the group. Okay, yes, students? Students, is that clear? Then what is the electronic configuration of indium? Simply you can write down the electronic configuration of indium, guys, right? So this you can also see what is the atomic number. Atomic number you can directly write. This is krypton 4d10 5s2 this. Now if I ask you, indium belongs to which group? Okay, tell me that. This so they have given you here also. I am not following this way. I am following my own way, right? So I'll tell you what is the largest value of principal quantum number? That is 5. Okay. Then what is the last electron is filled in which orbital? That is p, right? Then what is the group? Group will be 12 plus electron is 1. So it is 1. That is group number 30. Okay. Very good. Indium, we all know that it is belonging to boron group, ma'am. And acha, if you understand that, how you will tell the number of electrons here, right? How you will tell the number of electrons? So boron, hydrogen, helium, lithium, beryllium, boron, it is 5, right? Then you have to only add the atomic number, right? Acha, they are asking you the indium here, right? Indium you can't actually directly tell that from that particular thing here. This will be BALGAIN, right? So that means this is your period number 2, this is 3, this is 4, and this is 5. So here also you can directly answer that it is period number 5. So it's totally your choice how you want to answer it. You can answer it from understanding the table. You can answer it from the simple thing also, right? It's totally your choice how you want to answer it, right? Next is the IUPAC naming. So for IUPAC naming nomenclature, right? So if you see this here, it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So for 0, it is nil, 1 is un, 2 is bi, tri, quad, pent, hex, sept, oct, n. That is the name, right? Then what is the abbreviation that is given here? Now, if they ask you 101 here, this is un, then it will be nil, then it is un, then it will be IUM in the end, right? That will be IUM in the end, right? So easily you can answer the IUPAC naming. But the problem is they have asked the question based on the common name, right? The official name of these elements. So this is the table where you have the official name of these elements. But the problem is, ma'am, how to remember, ma'am, how should I remember the official names, right? So for that also, it is very important to understand how to write down the official names. For that, we have this very important. Now, you must learn this nomenclature chart. So when I give you this nomenclature chart, what is your idea on that? What is your reaction on that? How you will remember that, isn't it? Because beta, it was there. They're asking these questions, right? So how you will remember? Ma'am, we have to remember this. Aura has already given her reaction or his reaction, I don't know, right? So the reaction is, can you see what is mean by iodine, magnesium, oxygen, nitrogen, sodium, chromium, yttrium, right? What do you mean by that? I am gonna cry. What is this? I am gonna cry. So you're like, ma'am, I'm gonna cry, ma'am. Why you're saying this, ma'am? Do I have to remember this nomenclature? Why you're saying this, ma'am? Right? So to make you happy, not sad here. You should not be sad. You should be happy here. What we have, right? To make you happy here, we have these simple mnemonics for you. My name is Lawrence R.D. Mendeleevium, Nobelium, Laurentium, Rutherfordium, and Dubnium. Right? I am State Bank of Haryana, MD. Like they are introducing themselves. Ceoborium, then Bohemium, Hastium, Meternium, then Dalmatium. Right? These names are very tough. I run Copper National FM Live 2. Now, R is Rontengium, C Coprenchemium, Copernicium, right? Nihonium, then F for you have Flavorium, then M you have Moscovium, then L you have liver, livermorium, then T you have Tennessine, then O you have Orginescent, right? Okay. So I know these names are very irritating, very weird, right? And the chances of asking these questions are less, but still they have asked these questions. NT has asked these questions in other competitive exams. So chances are they can ask you this. I know it is very difficult to learn even with the mnemonic. Even with the mnemonic, it is difficult. But I have given you my mnemonic. You can make your own mnemonic, right? Even if you remember just one or two word here, right? You can remember Ront, you can remember copper, you can remember Miho, you can remember flare, Moscow, liver, right? You can remember tennis, then you can remember an organ, you can remember sea, bohar, you can remember hus, meat, darmet, dam, you can remember dam, you can remember Mendeleev, Noble, Lawrence, Rutherford, then do, right? These names you can remember, full you don't have to remember, right? Okay. Oh my God. Omega. Chal. Now this is your JEE previous year question only. The IUPAC nomenclature of an element with electronic configuration, this is, right? So now here they are asking you the IUPAC nomenclature. You can see this here, right? This is the IUPAC nomenclature of this particular compound they have asked you, right? For this, first you should know what is Rn, what is the atomic number of radon. This is a noble gas. What is the atomic number of radon, students? What is the atomic number of radon? Everybody, what is the atomic number of radon? Yes, everybody, what is the atomic? This you can answer easily. Atomic number of radon plus 14 plus 1 plus 2. Add that and then you can answer. D, but what is the atomic number of radon? Yes, everybody, this is your JEE previous year question only. This is JEE previous year question only. Very good, very good. D is the correct answer. Very good. Very good. Yes. So, 86 plus 14 plus 1 plus 2, that will 4, 5, 6, 7. 7 plus 7, 14 and 7 plus 6 is 13. 8, 9, 10. It will be 103. So, it will be uniltrium. So, answer will be D is the correct answer. Okay, very good. Very good. Okay. Now, this is in NEET 2020 they have asked. So, they can also, ask the previous year question here and there. So here they have asked you Mendeleev, Laurentium, Seobor, Darmstadt. That's why I gave you all that data, right? So if they can ask you this question in NEET, then why not in JEE also they can ask you the same thing, right? Okay. So what you will see, unnilium is Mendeleev, unniltrium is Lawrence, then unnilhexium, that is Seobor, then unnilium is Rotentium, right? Okay, so that you should remember only. That is a full-fledged cramming based question, right? Okay, understood? Understood, students? Understood, everybody? Yes. Okay, okay, okay. Wait a minute. Sure. Now, do you want me to take any break, right? Do you want me to take any break? Yes, students, do you want to take any break, right? Yes? You want to have break? Yes, ma'am. So after the break, we are going to do the rest of the part that is mostly related to not cramming, mostly understanding part we are left with, like shielding effect, what is inert pair effect, how inert pair effect affects the trend, what is ionization, all these things we will revise. Okay, students? Yes? Chal. Ma'am, I am watching your class for the first time, and how do you like it, and what was your reviews, right? On this you're watching from the first time. Ma'am, anything is fine, ma'am. How much more time? Yeah, it will take 1 hour more to complete all of that. What I can do before the break, I can complete this shielding effect here, right? Okay, I can complete the shielding effect here. Now, shielding effect is the decrease in the force of attraction on valence electron due to inner shell electron is screening effect or shielding effect. So, screening or the shielding effect is that because of the inner core electron, we know that in the outermost electron there are some inner core electron. When those inner core electron protect the outermost electron from the inner nucleus, because we know that nucleus is positively charged, electron is negative charge, it will attract, right? So nucleus is highly dense, electron is not at all dense. So electron cannot attract the nucleus, but nucleus can attract the electron. So when the inner core electron shield or screen the outermost electron from the nucleus, that is called shielding effect, that is called screening effect. Okay, that is called shielding effect, that is called screening effect, right? Okay, ma'am, when is chemical bonding? Don't worry, we'll get to that. We'll get to that as well. Don't worry about that. Right? Okay? Huh. Now, this understood now? So, what is shielding effect? This is inner core electron. This is the outermost electron. When it is shielding it, when the inner core electron shields it, the outermost electron, Z effective will be there. So, if the outermost electron, the amount of the nuclear charge that the nucleus have on the outermost electron is called nuclear charge, right? But when, because of the shielding effect, it protects the outermost electron, then the Z effective, the nuclear charge by the nucleus on the outermost electron, that decreases. Hence, Z effective is less as compared to Z. Okay, Z is more as compared to Z effective, right? Okay, now let us see here. If you see, as I told you, Z effective is total nuclear charge, that is Z, minus the screening constant, that is sigma. So sigma is called the screening constant. So when you subtract the total nuclear charge is usually equals to the number of protons. For example, in case of nitrogen, 7 protons you have, so it will be 7 minus sigma is going to be your Z effective. Okay, due to screening effect, valence shell experiences less force of attraction. There is a reduction in the nuclear charge due to screening effect. Reduced nuclear charge is called effective nuclear charge, that is Z effective. Okay, that is Z effective, right? Okay, now if you see how much screening effect, so everyone has different screening effect. So screening effect of basically it is inversely proportional to the diffusion. So we say that screening effect of S is maximum, then you have P, then you have D, then you have F, which has the minimum screening effect. Now why it is so? Now penetration effect or power, the ability of electron to get close to the nucleus is penetration. So what you will see now, because of the S orbital is a spherical lobe, so it can actually diffuse in the nucleus, right? It can interact with the nucleus more easily, right? So that is why the penetration of S is maximum. Then D, because of the double dumbbell shape, right? It can easily diffuse. F, because of its complicated shape, it has very poor penetration effect. That is why it has very poor shielding effect as well, right? Okay. So the ability of the electron to get close to the nucleus is penetration. That is very less for F orbital because of its shape. The more the penetration power of orbital, the more they shield outer electron from the nuclear charge, right? Outer electron is the outermost electron. This is the nuclear charge. More is the penetration. Penetration means they are very simple thing. Okay, in daily life, what we observe. This is you. This is your friend, right? Okay, so this is your friend. Your friend is holding you. If let's say your friend is not holding you properly, he is holding you from the small finger. So someone else is pushing you back. So easily you can lose, right? Why? Because your holding power with your friend is not very good, right? So that's why the screening will not be very good. So when F orbital, because of its complicated shape, it is not able to diffuse into the nucleus properly. That is why the holding with the nucleus is not good. That is why it cannot shield it properly, right? That is why it cannot shield it properly. Is that clear? Right? Okay. Okay, Ji. Now, factors on which, now other factors is that how close the electrons are from the nucleus. The inner electron will produce more shielding effect when the outer electrons will produce less shielding. It's very simple. Inner electron will be more attracted towards the nucleus. Outer, let's say you have these three things. So this is the outer electron, these are the inner electrons. So they will have more attraction. So that's why the shielding capacity of those will be more, because the diffusion with the nucleus will be more. Right? Okay? Understood? Everybody understood or not? Now, based on shielding effect, we will tell about that, ma'am. Yes. Okay. Now, based on the shielding effect, we will tell the properties, right? If you see this here, this is along the period, this will be down the group, right? So, along the period, as we move from left to right in a period, the number of electrons in inner shell remain constant. Therefore, shielding effect will remain same. So now what they are saying, you are adding one electron here. This is very important to understand. From left to right, the shielding effect remains same. That's why Z effective will increase. Why so? Because if you see this here, you have NS1, this is NS2. Same orbital you have, right? Let's say you have 1s1, this is 1s2. Here it will be 1s. Let's see, here you have 1s and you have 2 we will talk about. Okay, 2s, you have 2s2. Here you have 2s2, 2p1. Okay, 2s2, 2p2. So only one electron you are adding here, right? It's not like you are adding an entire orbital altogether, right? So one electron when you are adding here, what will happen? The shielding will remain constant only. It will not change, because same number of protons are getting added, same number of electrons are getting added, right? So because the shielding is constant, right? Because the orbit is constant, that is why the shielding remains constant and Z effective will increase. You can also understand with this simple thing that when you are adding one electron, let's say one electron, okay, then you are having one more electron, then you are adding one more electron, then one more electron, then one more electron. So as you add one electron, one proton also you are adding. When you are adding one electron, one proton, see along the period I am talking about, when you are adding one proton, you are also adding one electron. Both the things you are doing, isn't it? Along the period, you are not adding 6, 7 electrons entirely. You are adding one proton, one electron, one proton, one electron, one proton, one electron. That is the reason what is happening. By one charge, the proton charge is increasing. The attraction power is increasing, right? But the electron that is added is also one, right? So in the same orbital, one electron is getting added. So you can see earlier the proton was small and this was one electron. Now the proton is large and these are the 2 electrons. Now the proton is even large and these are the 3 electrons. So now what will happen? The proton on each electron will have more nuclear charge. Okay, the proton on each electron will have more nuclear charge. It's like you can say that there is a gang and there are different people here. If there is a gang, right, that gang, if you're adding one member to that gang, and they say na, whenever if you want to win over something, you have to be in group, right? Only then you can win. So it's the same thing. So when you're in a gang, you are adding one person to that gang, and individually also you are increasing one person. So that gang will attack on first side, then that gang will attack on the second side, then that gang will attack on the third side, then on the fourth side, right? So that means when it's like you will say that, ma'am, I am giving equal number, I am also adding member to the gang, I am also adding one electron here. So ma'am, both should have same like power, but electrons are alone, protons are in a gang. That is why Z effective will increase. That is why size is going to decrease. Better tell me, is that thing clear to all of you? Just imagine proton, positive charge you are adding here. Electron is 1, 1, 1, 1, 1. Electron is not in a group, it is revolving around like this, right, individually, right? And we have one nucleus is attacking on one electron. The power of nucleus has increased, but for one electron, it doesn't matter if you're adding one more electron. You should add like a group of electron which can provide shielding. Only then in that case something can happen, right? Okay. Now down the group things are different. Now down the group, if you see, we are not adding one electron. We are saying that it is NS1. This is, let's say, 2S1. This is 3S1. This is 4S1, 5S1. So it's like this. 1S, this is 1S. After so many orbitals, you will have 2S. After so many orbitals, you will have 3S. We know that between 2S and 3S, you have D and P orbital as well, right? You have D and P orbital. So they will act as shielding. They will shield the electron. So if you see this here, if you see the electronic configuration also, I'll just show you the electronic configuration here. If you see the electronic configuration here, students, if you see the electronic, if I see before 3s and 2s, you have 2p. So these 2p6 electrons are going to shield the outermost 3s electron. If you have only 1s to 2s2, 1s to 2s1, in that case, you only have 1s electrons that are shielding. In case of 3s, you will have these electrons that are acting as a shielding. So the power of shielding, now it's not like you are adding one electron. Definitely you are adding proton also. The power of the nucleus is also increasing. It's there. But you are also adding a new orbital only, a new subshell you are adding. When adding a new subshell, right, you can see before 4s, see, before 3s you have 2p. Before 4s you have 3p6. Before 5s you have 4p6 and 3d10, right? You have 3d10 also. Before 6s you will also have 4f, right? So many orbitals you are adding here. So that is the reason the shielding is increasing, right? That is the reason the shielding is increasing, and that is the same reason that the size will increase, because when the protection is more, when you have shielding, it's like when I am protecting you from something, then what will happen? Then that means you are being protected. That thing will not affect you. So when the inner core electrons are protecting the outermost electron from the nucleus, then the size will not decrease. But what is the harmful thing? That nucleus will attract the electron and the size will decrease. But here the size will not decrease. First thing is we are adding new subshell, right? So size has already increased, and moreover the shielding effect is strong. So that is why it cannot attract the outermost electron with that much effect. That is why Z effective, you can see it will increase down the group, right? What you will see is Z effective will increase down the group. Okay, students, as we move from top to Z effective almost remain constant, right? But size will increase here, right? You will see size increases down the group, and here size decreases. Okay. Now here, ma'am, you are saying Z effective is almost the same, right? We are talking about that Z effective is almost the same. Size is not almost the same, because you are adding the orbital here. It's just that two people were fighting, right? They cross-cancelled each other, right? So as we move from top to bottom in a group, the number of electron shell increases. As a result, shielding effect increases, right? Z effective almost remained constant here, right? Because as the proton is increasing, as the nuclear charge is increasing, the shielding effective is also increasing. So they are cancelling each other. That is why Z effective is almost same. And that is why when we are increasing the orbital, the shells, that is why when we are increasing rooms in a house, the area will increase, right? So when you're increasing subshells, the orbit, the area, the size of the atom will increase. Is that clear? Right? Okay. 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 Chal. Now, let us see the atomic radius. Atomic radius. Let us see the atomic radius. Wait a minute. Chalo, I'll show you that. Okay. Now, in a fast forward manner, we will do that because we are here for our revision for JEE 2026, right? So, atomic radius, you have covalent, you have metallic, you have van der Waals radius. If you talk about covalent radius, it is 1/2 of the covalent, means there is sharing of the electrons. So, that is why this is one atom, this is the other atom. So, this is going to be almost 1/2 of the internuclear distance between two atoms which are covalently bonded. It is also 1/2. It is exactly 1/2 of the internuclear distance. And when we talk about the van der Waals radius is between those atoms which are not transferring or which are not sharing any electron, right? So in covalent radius, they are sharing the electron. In metallic radius, they are next to each other, colliding with each other. But in van der Waals radius, they are distance apart from each other. In all the cases, we say it is 1/2 of the internuclear distance, but the van der Waals radius is the maximum. Then you have metallic, then you have covalent. Because in van der Waals radius, the actual radius will be less than, because half will be this one. This will be the half. And this is the actual radius. This is the actual radius. So the actual radius is less than what we will predict here. In this case, the actual radius is this one, but what we will predict is this one. Okay, so that's why the actual radius is more than the predicted, and here the actual and the predicted radius will be equal. Is that clear? Okay, chalo. Understood? Yes. Now, that this is what I told you about the atomic radius, right? Now, students, main important thing is the trends here. So along the period, because I told you before only, right, that along the period size will decrease. Why also I have told you the reason. Down the group, the atomic size will increase. Okay, so along the period, the size will increase. Down the group, the size will decrease. Okay, so number of orbitals remain constant. This all I have told you already, right? Now, one very important thing, right? This is the graph. What you will see in a group. Sorry, this is not in a group. This is along the period. This is along the period. So along the period, what you will see, the atomic radius is decreasing, decreasing, decreasing. Okay, the atomic radius is decreasing. But there is one important thing. Fluorine, after fluorine, you have neon. Noble gases, what will happen along the period? Atomic radius will decrease, but noble gases will have the maximum radius. Why? Because they don't react, they form van der Waals radius. That is why noble gases has the maximum radius. Okay, understood? Noble gases have the maximum radius here. Now, when you talk about down the group from top to bottom, what you will see that number of shells are increasing. That is the reason atomic size will also increase down the group. Okay, down the group atomic size will increase, and what you will see that lithium, sodium, potassium, rubidium, cesium, it is increasing. Fluorine, chlorine, this is about halogen, this is also increasing, right? So these are the general trends that will be useful in your P block and DNF block, right? Now, there are exceptions always there in chemistry, right? So let us see the exceptions of inorganic chemistry, and this is you. When exceptions of inorganic hit, you'll be like, okay, I'm done. I was happy learning the simple things, right? But in chemistry, they ask you questions from exceptions only. Yes, they ask you questions from exceptions, right? So that's why this is a very, very important exception of inorganic chemistry. That is 3D series. This you will also study in D block, right? That here what exactly will happen? that when you go along the 3D series, what will happen? This is Steve Karman. In detail, you will study about this in D block. Okay, in detail, you will study about this in D block, right? So, right now, just understand that this thing you will study, right? Right now, try to understand the general trends only. Okay, so here, full detail you will understand due to the increase in the nuclear charge. Okay, so what happens? Saktiv kar. Here what will happen? The nuclear charge will increase, right? Right, and in this case, what will happen? Size will firstly decrease. Then it will be nearly same. Manganese, iron, copper, cobalt, nickel, all will have same. Then size will start increasing, right? That is a very important exception, right? The transition series in the covalent radius of the element decrease from left to right across the row until near end when the size increases, right? What will happen from manganese to nickel? The screening and the nuclear charge will become approximately equal, and towards the end, the screening effect will be more, right? That is why its size will increase, and in the starting, nuclear charge will be more. So when Z effective, see, simple thing is Z effective, when it increases, it will try to decrease the size. So here Z effective is more. That is why size decreases. Here Z effective and screening effect is same. That is why size is same. Here screening effect is dominating. That is why size is increasing. Right? All these things are dependent on the electronic configuration, the orbitals. These things are important here. Right? Okay. Chalo. Then the size difference is also observed in, this is P block. Beta, what I'll do now, I'll just, I'll give you like thoda bahota detail. Reason being because this all is there in P block. Okay, this is there in P block. Now what will happen here? This is boron, this is aluminium, gallium, indium, thallium. Now what will happen? This is down the group. We were assuming that the down the group the size should increase, but in reality what will happen? Gallium should have more size as compared to aluminium, but in reality aluminium has more size as compared to gallium. Can you tell me why? Can you tell me why? In reality what will happen? This is having 3D orbitals. That is why, because we know that S shielding is S, then P, then D. This is the shielding. So because of the poor shielding effect of this D orbitals, the size of gallium will increase. And hence the actual order will be boron. Then instead of aluminium, gallium, it is gallium, aluminium. Then it is indium, then thallium. So this is where you will see the exception. That is because of the poor shielding. You know, all the exceptions in inorganic chemistry are because of the poor shielding effect of either D electrons or F electrons, right? Okay. Now, if you see this here, even here you will have exception. That this is also there in D and F block. I am telling you, everything will be repeated. That's why I am doing it in fast manner. So this is 4D, this is 5D series. What you will see that 4D and 5D series have equal radius. Reason being poor shielding effect of 4F. So what will happen? We know that here you have addition of 4F lanthanoids. So 4F will be added here. 4F has a poor shielding effect. What should happen here? The size along of this should decrease. Okay? But what will happen? Because here also you will have 4F, here also you will have 4F, here also you will have 4F, 4F. In all these electronic configuration, 4F will be filled. That is the reason when you are filling the 4F orbitals here, when you are filling these 4F orbitals here, what will happen? 4F orbitals will be filled here. But the problem is, what is the problem? But ma'am, the problem is when we are filling the 4F orbitals, there is poor shielding effect of 4F orbitals. That is why the outermost electron will get attracted towards the nucleus, and hence the size of these will decrease. What should happen? Down the group size should increase, because of 4F orbital the size is decreasing here. So 4D and 5D series have approximately the same size. That is why we say that zirconium, hafnium, all these elements have the same size. That is called lengthenoid contraction. You will study about this in more detail in DNF block. Okay, right? Then ionic radii. If you talk about ionic radii, for ionic radii, what is important for you, right? What is important for you? That is isoelectronic species, right? Iso, they ask you questions from isoelectronics. So let us see. Distance between nucleus and outermost electron. The ionic radii can be estimated by measuring the distance between cations and anions in the ionic crystal. The radius of cation is always smaller than their parent atom because you are losing the electron in cation. Anion, you are gaining the electron. That is why the radius will always be greater, right? Now, anionic radius, more the negative charge, more will be the anionic radius because you are adding the electron. As you are adding the electron, right, the size will increase. When you are taking out the electron, the size will decrease, right? So that is why as you take out the electron, positive charge will increase and the cationic radius will obviously decrease, right? Like you have M2 positive, this is M positive, this is M. So M has the highest size. And if you talk about M negative, then you will have M2 negative, right? So more the charge on the anion, more is the size, more the charge on the cation, less is the size. Okay, understood? Now let's talk about isoelectronic species. Isoelectronic species are which have the same number of electrons, right? So you can see this here, N. Nitrogen is 7. 7 plus 3 is 10. Oxygen is 8. 8 plus 2 is 10. Fluorine is 9. 9 plus 1 is 10. Neon is 10. Then sodium positive. Sodium is 11 minus 1 is 10. Magnesium is 12. 12 minus 2 is 10. Aluminium is 13. 13 minus 3 is 10. So that means the number of electrons are same here. These are these are the isoelectronic species. And in the isoelectronic species, the simple funda is how the size will matter. More the negative charge, more will be the size. More the positive charge, less will be the size. Okay. So if you want to talk about the size here, the size will be maximum for N. This is going to be the size. More the positive charge, less will be the size. So the size is going to be this thing, right? So directly just remember this thing here. Size is directly proportional to negative charge, inversely proportional to the positive charge, right? Okay, understood? Now this is very important question. You can see JEE previous year question. The correct increasing order of ionic radii, you can see this here. Correct increasing order of ionic radii, right? That will be according to the size here, right? You can see this here, right? That is the calcium 20, this is 16 plus 2, 18, 18, 18. These are 18 electrons. 19 minus 1 is 18. 16 plus 2 is 18. Then you have calcium, that is also 18, 18. All have 18 electrons. So calcium 2 positive minimum, then you have K positive, then you have Cl negative, then you have S2 negative. You just have to write it in the order of the increasing charge, negative charge. And that will be the answer. So answer is C is the correct answer here. Okay, answer is C is the correct answer here. Now let's talk about 2-3 more things. That is, first is ionization enthalpy. So when you talk about ionization enthalpy, now guys, I will not talk about more trends here, right? Because trends you will automatically study. What you will not study in P block and DNF block is the question that what is ionization enthalpy, right? Okay, that you should know before starting 12th. So amount of energy required to remove the most loosely bound electron from isolated gaseous atom. So this is your gaseous atom. Isolated, not in any reaction. You take out the electron, the energy that is required, right? You need to give the energy to the atom. Now, the energy required, required by us so that we can take out the electron here, that is called ionization energy, right? Okay. And Ionization energy is equals to, for example, this is living in n is equals to 1 orbit. So ionization energy will be negative of n minus 1 orbital, right? Okay, understood? Because electron will have same energy of in which orbit it is placed in, right? So ionization energy will be negative of that. Now, when you talk about ionization energy, which will have more and less ionization energy, so remember that when you have a neutral atom, you are taking out electron. It's still easy. But you have, when you have a cation, it's a positive charge. It's difficult to take out electron from there. Then you have more positive charge. It is even more difficult to take out electron from there. So as the positive charge on that atom increases, the difficulty of taking out the electron from that atom also increases, right? So that is why IE3 is maximum, then you have I2, IE1 is minimum. This is the general case. But if, let's say, after losing the electron, it is getting into a stable configuration. Let's say you have 2p5, right? After losing one electron, it is 2p4. After losing one more electron, it is 2p3. So this will require IE1. This will require IE2. You know, now IE1 will be greater than IE2. Can you tell me why? Because when it is getting converted to a stable half-filled configuration, losing the electron will become easy. When it is getting converted to a stable fully filled configuration, losing the electron will become easy, right? Okay, so losing the electron will become easy when you are losing the electron and getting converted into a stable electronic configuration, right? That is half filled or fully filled, right? Okay, is that clear? Right? Okay. So this is the same thing that I told you. Second ionization therapy is greater than first ionization therapy. Energy required to remove the electron from atom, which is always possible. Now this is important. That energy is always required. That is why these are the important things that will be useful in class 12th. When you will study DNF block, when you study P block, you will get lost if you have no idea what is ionization enthalpy, right? Ionization enthalpy will always be positive. Okay, it will always be positive. It cannot be negative. Energy is always required, right? The second ionization enthalpy is greater than first, that we have talked about, and third is greater than second. This also we have talked about, right? Now, low ionization enthalpy can be corrected with their high reactivity. So now what they are saying is, this is a variation of ionization enthalpy. Helium, see, noble gases, why they have maximum ionization? Can you see? Helium has maximum ionization enthalpy. See, helium does not, noble gases are like, I have octet is complete, then why would I want to lose the electron? Am I stupid or psycho? You are stable, you have your JEE seat, and still you are saying, I will not accept this seat, right? That means you are stupid, right? So when you are actually stable, you are noble, then why would it want to lose any electron? So that's why noble gases have highest, noble gases have the highest electronic configuration. I'm saying highest ionization enthalpy in that period, right? Now, if you see, IE is inversely proportional to the size, right? As along the period, size is decreasing, ionization enthalpy will increase. Can you tell me why? Size is decreasing means one size is this size, other size is this size. So this has a bigger size, this has a smaller size. So what will happen? The smaller size will have more attraction with the nucleus. So it's difficult to lose the electron. But the bigger size has less electron. The outermost electron will have less interaction with the nucleus. So it is easy to lose the electron. That is why size is inversely proportional to the ionization enthalpies. Okay, this we have talked about, right? This also I have told you that for a stable configuration, IE value, if you take out the electron, let's say you have NP3. Now in that case, you can't take out the electron from NP3. Yes, you can easily form from NP4 by losing one electron, you can form NP3, but to take out electron from this NP3 is very, very difficult because this is a very stable electronic configuration. So that concept should be in your head, right? Okay, understood? Yes, students. Penetration effect, now same thing, right? If let's say we have s orbitals, the inner core electrons, then to take out electron from s orbital, it is difficult as compared to p, as compared to d, as compared to f. So as the electron will experience greatest effect of effective nuclear charge when s orbital, then p orbital, and so on. Hence the order of electronic IE is s, then p, then d, then f. Why? Because S, we have talked about penetration effect. S has maximum penetration effect. Because of its maximum penetration, it is able to diffuse maximum with the nucleus. That is why we can't, it has very strong attraction with the nucleus. We can't take out that electron very easily, right? That's why it is very difficult to take out electron from s orbital. Then p, then d, then least difficult is from F. Okay, is that clear? Is this point clear to everybody or not? Right? Beta, these are this. I'll tell you what exactly we are talking about. The same thing I told you about exceptions. So here is the exception. This exception is very important because this is a period in exception that might or might not be there in P block. Some teachers can teach you that, some teachers can skip also. So it is basically a part of periodic classification only, that when you go lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, you'll be like, ma'am, here along the period ionization enthalpy should decrease, right? Yes, ma'am, neon has the maximum, but ma'am, it should, ionization enthalpy should increase, right? Ionization enthalpy along the period should increase. But in reality, what will happen? Beryllium has 1s2, 2s2. Nitrogen has 1s2, 2s2, 2p3. That is the reason beryllium will have more as compared to boron. Nitrogen will have more as compared to oxygen, because it is very difficult to take out the electron from half filled or fully filled. This is fully filled, this is half filled. That is the reason beryllium, it should be like this. It should be lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. In reality, what happens? Nitrogen, it will increase, beryllium, it will increase. And that will be the correct answer. Okay, this is a very, very important exception. Okay, this is a very, very important exception. Mark this. Right? Already I have explained you. The reason is fully filled and half filled electronic configuration of beryllium and nitrogen. Right? Now down the group, simply it will decrease. Okay, moving down the group, ionization enthalpy will decrease because the size is increasing. As the size is increasing, it is easy to lose the electron, right? Okay. Then, beta, this is from P block only, so I'll leave it to P block only, right? Okay. Right. Let's not talk about P and D block here, right? Let's not talk about P and D block here, right? Okay. This is also, will not talk about that here. Right? Wait a minute. The group 14 and the group 14 elements A and B have first ionization enthalpy values of this and this respectively. The above values are lowest among their groups. The nature of this and this also you will do in P block. Okay, you will not do it here, right? We will not do it here because periodic classification is a base. Right? We can't teach you P block in periodic classification, right? So that's why the guidance is needed, right? So if you see this here, the second period elements correct increasing order, that was a question of NEET, and this also they have asked in JEE so many times, right? This the same thing that I told you, that is C, exception is here, exception is here, right? Okay, that's why this question is important. Then there is electron affinity. Electron affinity is the gain of electron. Now here you should understand two major concepts. That is, when you gain the electron, right? Two things are there. One is electron gain enthalpy. Other is electron affinity, right? Now you all have to tell me one thing. I'll just put it in the poll. Okay, I'm asking you one question here. You have to tell me, ionization enthalpy will always be positive. Is it true or false? Ionization enthalpy will always be positive. Is it true or false? Is it true or is it false? Anybody? Ionization enthalpy will always be positive. Is it true or is it false? 71% of you are answering yes, ma'am, it is true. Very good. Now, tell me, now let's talk about electron gain enthalpy. Will this always be positive or negative? If you talk about electron affinity, that means the energy released when an electron is added to an isolated gaseous atom to produce a monovalent ion known as electron affinity. Right? Enthalpy change of this process is known as electron gain enthalpy. Minus sign indicates that electron energy is released here. Now, the question is, what is the difference between electron affinity and electron gain enthalpy? See, electron affinity is the capacity, the power, the want. For example, you are very hungry, right? You want to eat pakoras, you want to eat dosa, you want to eat pizza. So that is your capacity, that is your affinity towards pizza. So if I give you pizza, you will have positive affinity or negative affinity. If I give you pizza, you will have positive affinity towards it or negative affinity towards it. Tell me, positive affinity or negative affinity? And you guys have not liked the session, I can see that, right? Those students who are watching it for recorded as well, do like the session, right? It's like you're disrespecting me by not liking, by not sharing, right? So it's like when you will give your exam, the examiner will give you no marks. How you will feel? After doing preparation also, the examiner will be like, you have answered it correctly, but still I will not give you marks. Right? It's the same feeling. It's the same feeling, right? If you want me to go through that feeling, then that's your choice, right? So electron affinity can be positive, it can be negative, right? Electron affinity can be positive, can be negative. But when I am saying that you want to eat pizza, you are like, yes, I want to eat pizza, I love pizza. But tell me, do you have electron affinity? You have affinity for khichdi. Do you have affinity for dal? Do you have affinity for boiled foods, fruits, boiled vegetables? Do you have affinity for that or not? Do you have affinity for khichdi? Do you have affinity? I don't have affinity for khichdi. My affinity for khichdi is negative because I don't want to eat khichdi, right? So same is with electron. Electron affinity means does that atom want to gain the electron? That means affinity is positive. Does that atom want to gain the electron? If affinity is negative, that means it does not want to gain any electron. Okay? Yes? Okay? Understood, beta? Now tell me one thing. If affinity is positive, then electron gain enthalpy will be positive or negative. Right? If affinity is positive, then electron gain enthalpy will be positive or negative. If I am saying that, let's eat pizza, right? She'll be like, yes, I want to eat pizza. Then when you will eat, You will feel happy or sad after eating? You will feel happy after eating, right? So after eating, you will release energy, you will be happy. So that's why electron gain enthalpy will be negative. So always affinity and gain enthalpy are, the signs are opposite. This is the energy that is released or required when you gain the electron. This is the capability of gaining the electron, right? So, okay, sure. Okay, that is done. Okay, students. Now, minus I indicate that energy is released, electron affinity is this, that is this. Now, let us talk about this thing here. So, now, beta, there is one very important thing. What you can see, this is electron gain enthalpies, right? This, let me just correct it here. Right? So, here what is happening? Here, the electron gain enthalpy is negative. That means they are very happy. Their electron affinity is positive. Their electron gain enthalpy is negative. That means halogens want to gain electron because halogens are Ns2Np5. After gaining one electron, they will become noble gas configuration. That's why they want to gain the electron. That's why their electron affinity is positive and their electron gain enthalpy is negative, right? But if you talk about this thing here, noble gases are already stable. They don't want to gain anything. So their electron affinity is negative, but their electron gain enthalpy is positive. That's why here you will see electron gain enthalpies are positive. Is that clear, students? Is that clear? This is the major problem that I have seen in students, that they don't know what is the difference in electron affinity and electron gain enthalpy and how the signs are opposite, right? So if they give you noble gases have negative electron affinity, but they have positive value of electron gain enthalpy. That means if you forcefully want to give the electron to noble gases, you will have to give the energy as well, right? It's not like they are very happy after losing. And noble gases are the only one which has negative electron affinity. Okay. Now, electron affinity is inversely proportional to size, same as ionization enthalpy. It is same as ionization enthalpy. It is also inversely proportional, right? Now, atoms having above configuration is most stable. Most stable elements do not have tendency to accept extra electron. That is why noble gases do not want to accept any electron. Now you can see along the period atomic size is decreasing. That is why electron affinity to gain the electron will increase, right? Okay. Reason being because the Z effective will be more here. So that is why the gaining power will be more here, right? Okay. Down the group, the values of electron affinity, noble gases are 0 because there is outermost affinity fully filled electrons of p orbital. Noble gases, electron affinity is 0. In some books it is written as 0. In some books it is also written as negative, that they don't want to gain electron, right? Okay. Now, this is the exception part only. Okay. This exception part, usually from electron affinity, the exceptions are asked very rare, right? So I will not get into the exception part of P block. But you can see along the period beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, right? So you can see electron affinity of beryllium is less than boron, right? And electron affinity of nitrogen is less than electron affinity of carbon, right? That is very, very important, right? Because nitrogen, if you see, nitrogen is fully filled, right? Beryllium is also fully filled. So what should happen along the period? It should increase. Electron affinity, yes, it should increase, right? Electron affinity should increase, right? But definitely boron will have more. And here we are saying that, wait a minute, you know, beryllium, so it is right. Beryllium, boron. Wait a minute. Beryllium does not want to gain, that will be less. So that is true, electron affinity of beryllium will be less than boron. But here if you see, they are saying that carbon is having less as compared to nitrogen, which is wrong. Why? Because nitrogen is half filled, stable configuration. So it does not want to gain any further electrons, right? It does not want to gain any further electrons. So that is why nitrogen will have less electron affinity as compared to carbon, right? Rest of the things, they are there in P block, right? We will discuss that in P block only, right? And this is the actual order what you will see: beryllium, oxygen, carbon, boron, nitrogen, and then beryllium. This is the actual order. Beryllium also does not want, nitrogen also does not want. This is fluorine wants, because just by gaining one electron it can shift to noble gas. Then oxygen wants to gain, carbon wants to gain, boron wants to gain. So that's why this will be the actual order that you should know. Right? This will not be discussed in P block. Okay. Chal. Now, atomic sizes increases with decrease in effective nuclear charge, hence decreases in the electron affinity. This is down the group we are talking about, that electron affinity will decrease. But the exception is the value of electron affinity of alkali metals and alkaline earth metal regarded as 0. Can you tell me why? Because alkali metals, if you remember that metals are electropositive in nature, right? Metals do not want to gain the electron. They want to lose the electron. That's why their electron affinity is regarded as 0, because they do not have tendency to form anions by accepting the electron. So that you should remember, right? Okay. Then we have this also you can. This you can do. This you can do, because there is no as such relation. In which of the following pair electron gain enthalpy of constituent elements are nearly same or identical? Now they are saying which is the electron gain enthalpy of constituent elements are nearly same. Choose the correct answer from the options given below. So the options are given to you, these elements, right? So you have to choose which have the nearly same electron gain enthalpy. If you see rubidium and cesium, right, and argon and krypton have nearly same value. I have nearly same electron gain enthalpy, that is -47, have same value, that is plus of 96. These are the adjacent elements, right? Okay, they don't have difference, right? So they are the adjacent elements which have the same electron gain enthalpy. So that was a fact based question. Okay, so these are directly from the tables, right? Okay, you can see A and C is the correct answer. Next is which of the following rearrangement is in the correct order of less negative to the most negative. Now this is the problem. Now least negative, what do you mean by that? Acha, tell me one thing, other things are facts only. Tell me, what do you mean by this question? Least negative to most negative electron gain enthalpy. Least negative means what? Electron gain enthalpy is least negative. That means less energy is released. That means they didn't have any tendency to gain the electron, right? That is why we will see from less tendency to more tendency. Firstly, you should understand this thing, which has less tendency to more tendency. We want to see, first you will pick out that option which has less tendency to gain the electron, then move towards which have more tendency to gain the electron. So you can see here, right, the order is going to be from less tendency to the more tendency, that we have discussed here also. Electron gain enthalpy becomes less negative from top to bottom in the group, while it becomes more negative from left to right within the period. So answer is going to be D, because if you see this here, this is aluminium. Here in the group 2 you will have calcium. This is carbon. This is oxygen. This is fluorine. Right? Okay. And this is your calcium. And this is boron. Now, what you will see here, right? We know that along the period, electron gain enthalpy increases or decreases. electron gain enthalpy will become more negative, right? The tendency to gain the electron will be more, right? So it will be like this, right? Okay. And down the group, the tendency to gain the electron will be less, right? So here it will be calcium, then you will have, wait a minute, that will be less, no? So aluminium, this is aluminium. Down the group, it is decreasing, na? So, acha, boron you didn't have. Okay, okay, my bad. Okay, boron you didn't have. Okay, so calcium, then aluminium, then carbon, then oxygen, then fluorine. So answer will be D is the correct answer. Okay, so that's how to answer this, right? Okay, now electron negativity. What is electron negativity? So students, electron negativity is once you have shared pair of electron, right? Those who don't know what is shared pair of electron, watch my basic lecture of inorganic chemistry, right? Shared pair of electron you have. Now, when this shared pair of electron is more towards A, this is more electronegative. When this shared pair of electron is more towards B, this is more electronegative. So, when the shared pair of electron is more towards one atom, that is more electronegative, right? And there are different scales to identify the electronegativity. First is Mulliken gave the electronegativity as the average value of ionization potential and electron affinity. That is ionization potential plus electron affinity divided by 2 will give you, according to Mulliken scale, that will give you the electronegativity. Then according to Pauling scale, the formula is electronegativity A minus B, that is going to be 0.208. This is bond enthalpy, bond energy of AB bond minus under root of bond energy of AA bond multiplied by bond energy of BB bond, right? Usually they don't ask numerical based on these things. I'm just telling you the formulas here just so that what if they ask you, then you should know, right? Okay. And fluorine is assigned as 4. Fluorine has the maximum electronegativity and the value that they have assigned is 4, right? This also you should remember the important values, that carbon, sulfur and iodine, you can also remember this by cis, that is having 2.5. Nitrogen, chlorine has 3. Phosphorus, hydrogen has 2.1. Cesium, francium has 0.7. Beryllium, aluminium has 1.5, right? You can also remember it like this. Fluorine is 4, then 0.5 you will decrease to 1.51. That you can remember from lithium to fluorine, at least you can remember the electronegativities of this period, and then you can remember the electronegativities of these things. Fluorine, you should definitely know that fluorine has 4 electronegativity, right? Okay. Then there is Alred-Roschow scale. Now in Alred-Roschow scale, what you have is electronegativities Z effective E square by R square. Now this is also written as 0.359 Z effective by R square plus 0.744. Z effective is the nuclear charge and R is the covalent radius of the atom. But these are never asked till now, so they have not asked any question based on these formulas. That's why I'm just giving you the formulas, right? Now, what are the factors? Factors are important for you. Factors affecting, trends are important, right? So, factor is that size C. One important thing till now, what we have observed, size is inversely. You can say ionization enthalpy, electron affinity, electron negativity, all are inversely proportional. Acha, inversely proportional to the size. All are inversely proportional to the size. And when I say along the period size decreases, electroaffinity also, size decreases, electron affinity increases, right? When I say electron affinity is increasing along the period, then you must remember that the capacity, the want to eat the electron increases. That means that if you want to eat the electron, your positive value of electron affinity will increase, negative value of electron gain enthalpy will increase. That means you will release more energy, right? That is a very important concept. Okay, so now size and charge we have seen, that is inversely proportional. Now charge on the cationic species, what you will see, More the charge, more the positive charge, more will be the electron gain enthalpy, right? Because they are electro deficient, that is why they would want to gain the electron, right? So greater the charge on cation, greater is the En value. More is the charge on anion, less will be the En value. If you have more charge, you would not want to gain any electron, right? Because you already have electron, you already have extra electron, so it does not want to gain any electron, right? Then this is a very important concept that is also used in organic chemistry, right? This is also used in organic chemistry. This, so you will see so many times in organic chemistry, especially in chemical bonding. So hybridization, sp, sp2. What is hybridization? That you can see my inorganic base. Inorganic base I have already taken. You can watch that lecture, right? And in detail, I'll teach you hybridization in chemical bonding. Okay. So here what you have, sp, then sp2, then you have sp3, right? So sp has maximum electronegativity because s character is maximum. So more the s character, more is the electronegativity. So sp, then sp2, then sp3 is the electronegativity order here, right? Atomic size. Now we know that this I have already told you that it is inversely proportional. Okay. Now, very important thing. I'll just write it here only. You know, along the period, size increases or decreases? Ma'am, size decreases along the period. If the size is decreasing, you know, along the period, one more thing happens. Along the period, the metallic character, you can say non-metallic character increases, right? Okay, so you can see non-metallic character. What all are the things that are increasing? Non-metallic character is increasing, ionization enthalpy is increasing, electron affinity is increasing, electronegativity is increasing, but size is decreasing along the period. That is very important conclusion that you can draw from today's lecture, right? Okay, that will really help you, right? So these are this is what is given in your NCERT. I would really advise you that this full table, if you don't want to learn any electronegativity, this you should definitely remember, right? Why this? Easily, it's not a big deal to remember. Fluorine is 4. Subtract 0.5, 0.5, 0.5, 0.5, 0.5, 0.5. Then chlorine is 3. 0.5, 2.5, 2.1, 1.8, 1.5, 1.2, 0.9. Right? Okay. So that's how you can remember. Right? Okay. This one is still difficult, but that lithium to fluorine is easy to remember. But this, why I'm asking you to learn this, because you never know, they can ask you factual based question they are asking, right? So trends of electronegativity also we have seen, right? Now non-metallic character is increasing along the period, and down the group non-metallic character is decreasing. That is why metallic character is increasing, right? Okay. This is again the order only, right? Electronic configuration of this are given below. Which of the following is correct order of increasing electronegativity? So basically, this what they have given you is the electronic configuration. They are asking you the electronegativity order. So you can just write the number here: 3, 4, 5, 6, 3, 4, 5, 6, 7, right? Means nitrogen. 4, 5, 6, 7, 8 means oxygen. 5, 6, 7, 8, 9 means fluorine, right? 2, 3, 4, 5, 6 means carbon. So you already know which has, hai na? Fluorine will have the maximum. They are asking you in given below, which is the order here. So order we already know which has the maximum. Fluorine, okay, nitrogen, then you have oxygen, fluorine, oxygen, nitrogen, then you have carbon. What is fluorine? Where is fluorine? Fluorine is C, oxygen is B, nitrogen is A, carbon is D. That's how you can answer this, right? Okay. That's how you can answer this. Answer will turn out to be A as the correct answer. Okay. Then students, we have the application of electronegativity. It's not like applications are not restricted to this only. There are other applications as well, right? So you can see that first is the metallic character. Metallic character is inversely proportional to the electronegativity, or non-metallic character is directly proportional to the electronegativity, whichever you want to learn. Now, along the period, electronegativity increases. That is why non-metallic character also increases, right? Second is bond energy. Now, how bond energy? See, if the polarity is more, when the electronegativity difference increases between two bonded atoms, the polarity increases, the attractions increases, the bond energy also increases, right? So if you see, you have two elements which have very high difference in electronegativity. So one will be have positive polarity, one will have negative polarity. So they will also have attractions, force of attraction with each other. That is the reason the bond will be very strong. Will be very difficult to break that bond. Okay, understood? So bond energy also increases if the difference increases. So you can say now, if delta En is more, bond energy is more, right? If bond energy is more, bond length is less. Always remember, bond energy is inversely proportional to bond length. Okay? You can also remember this by directly proportional to bond order. Bond order you will discuss in chemical bonding. As I have written it here. You can also ignore this part because eventually you are going to study this part in bond. In chemical bonding, you will study about bond length, bond energy in detail, right? So we know that as the difference in En is increasing, the bond energy is also increasing. That I told you how, because interactions are increasing. Because I am saying that it is very difficult to break this bond. That means the length is very short. We know that, see, if a stick is very small, it is very difficult to break that stick. If that stick is very large, it is very easy to break that stick. Okay? So that's how you can remember. Right? Then nature of bond, how you can tell the nature of bond here. The difference in ENA and ENB, it equals to 0. That means both are same. Then the bond is purely covalent. See, if there is no electronegativity difference, the bond will be purely, there will be not even 1% interactions because there will be no polarity difference, right? Percentage ionic character may be calculated by using, if you have, let's say, this electronegativity of A and B are not equal. Then how you will calculate the percentage ionic character? This is an important formula. This is an important formula, students. You can mark it important. Electronegativity of A and B will be given to you in the question. They can ask you what is the percentage ionic character, what is the percentage covalent character. Percentage ionic character is equals to 16, the difference of electronegativity, plus 3.5 difference of electronegativity square, right? That is percentage ionic character. So when you subtract it from 100, that will be a percentage covalent character. Okay. Then what else you can predict here is acidic strength of hydrides. Now, acidic strength is, we can say that in a particular period, acidic strength of hydride depends on the electronegativity of M in MH bond. You have MH bond, right? More is the electronegativity of M, more will be the acidic strength. That is why this is the acidic strength, right? This we are talking about along one period. We know that they all belong to one period. Nitrogen, oxygen, fluorine. Fluorine has maximum electronegativity. That is the reason it has maximum acidic strength, right? Okay. Then nature of hydroxides. How? As per Gallus, AOH, if electronegativity of A is more than 1.7. Now, ma'am, how electronegativity of A is more than 1.7? Then it is acidic in nature, right? This is the standard factual based thing that if AOH, if the electronegativity of A is more than 1.7, that means it is a non-metal, it will be acidic in nature. If A has less electronegativity, that means it is a metal, then it will have a basic hydroxide. So we know that all the metals have basic hydroxides or oxides, all the non-metals have acidic hydroxides or oxides. Reason is because of Gallus scale, right? Okay. Then this also, nature of oxide. Now we are saying that if the difference with oxygen is constant, if there is A and the difference between A and O is greater than 2.3, if it is equal to 2.3, if it is less than 2.3. Now it is greater than 2.3, basically they are talking about metal, then it will be a basic oxide. If it is equal to 2.3, these are amphoteric oxide. If it is less than 2.3, it is the acidic oxide. Okay, and from the oxides they ask the questions. Okay, not from the calculation but from the examples. Like they can ask you chlorine oxide is acidic or basic. Chlorine is a non-metal, it has the acidic oxide. Amphoteric oxides are like zinc, tin, lead, aluminium, right, vanadium. All these oxides of all these elements are amphoteric in nature. And there is one more oxide, that is neutral oxides. This also they ask. Neutral oxides are like Cu, N2O, right? Then NO. These are the neutral oxides that you have, right? Okay. Next is this, as I told you, metal oxides are basic, aluminium, silicon, these are amphoteric, these are non-metal oxides that are acidic in nature, right? Okay. So now here, when in a periodic table, the distance between element and oxygen increases, what you will see, wait a minute. So it means they are saying when the periodic table, the distance between element and oxygen, right? That element and that oxygen, when the distance between element of oxygen increases, the basic character is going to increase. That means opposite of acidic character they have given you here, right? Next, let us see that. This is also done. Next is neutral oxides. This I have told you. These are the neutral oxides. These are very, very important. These are the number of amphoteric oxides. These examples are also very, very, very important, right? These examples should be on your tips, right? What are beryllium, aluminium, zinc, tin, lead, then antimony? All these oxides should be on your tips, right? What are amphoteric, what are neutral? Mostly they ask you about amphoteric and neutral. Okay, then yes. Now also understand one thing, acidic strength is directly proportional to the oxidation state. Okay, oxidation state, except for exception is oxyphosphorus acid. Ma'am, when we will study oxyphosphorus acid, this you will study in P block. Okay, in P block you will study oxyphosphorus acid. There you will see this acidic strength directly proportional to oxidation state is not applied on the phospho-oxy acids. Okay, it is the opposite, right? Now here, this is JEE previous year question, that is group 13 elements react with O2 in amorphous form to form oxides of type this. Which among the following is most basic oxide? Most basic oxide they are asking you. See, we know that down the group metallic character increases, the basicity will increase, right? So most basic oxide is going to be of this Tl2. So answer is going to be B is the correct answer, and Al and Ga have the amphoteric oxide. Ma'am, will this be repeated in P block? Yes, that will be, because now you have answered it. See, there are two questions. Okay, this question can also be answered based on the metallic and non-metallic trends, right? But in P block, you will study that which oxide is amphoteric, which is acidic, which is basic. In each group of 13 to 18, you will study that. Okay, so that will help you in that, right? Okay, now application of electronegativity, guys, you have, right? I think this is the last topics, right, that we have, right? Chalo, let us study that. Okay, rest of the things are repetition only, right? So here we have hydrolysis of products of X. Now here very simple thing I'll tell you here. So if you talk about hydrolysis or product of AX, okay, you have A and X. After hydrolysis, what you will have? See, if the electronegativity of X is greater than electronegativity of A, then on hydrolysis, the product will be HX. Okay? Why? Because H is always positive and it will link to a more electronegative element. If X is electronegative, this will be the product, right? But if I say that if electronegativity of X is less than electronegativity of A, then on hydrolysis, what you will have? Beta, hydrolysis is H positive, OH negative, right? If X is greater, if X is negative, then X will be attached here and A will be attached here. You will have HX and you will have AOH here, right? But in this case, when X has less electronegativity, you will have A here. Wait a minute. A will be more electronegative, na? A will be here and X will be positive, that will be here. In this case, you will have HOX as the answer, that is hypohalous acid, right? Okay, understood? How you will predict the product of hydrolysis, right? So for example, on hydrolysis, they have given you OCl. OCl2 they have given you. Now, which is more electronegative, oxygen or chlorine? Oxygen is more electronegative, right? So what will happen? What will happen? This oxygen will combine with this H and with this H, that will give you H2O. And these Cl will combine with this OH, it will give you HOCl. HOCl. Okay, that's how you can predict the product of electrolysis, right? And example is ClO2, right, where oxygen is more electronegative as compared to chlorine. Understood, students, that how with the electronegativity difference you can give the products here. Just remember that 2H you will have more electronegative element. To this you will have less electronegative element. Okay, that's how you can give the product of hydrolysis. Is that clear to everybody or not? Right? But these I am deleting only because these are from P block only. Right? This you can study in P block. So there is no use of doing that here. Right? Then there is metallic character. In metallic character, what we have? Metallic character of element increases from top to bottom. This we have understood that, okay, metallic character is increasing, non-metallic character is increasing along the period, right? So it can be correlated with the trends of electronegativity. This can be best seen in group number 14 elements, that is here, right? So what we can see, non-metal, then metalloid, then metalloid, then metal, then metal. Then yes, down the group, metallic character is increasing, right? Okay, it will be throughout the periodic table. Along the period, non-metallic character is increasing, as you can see here. Okay, along the period, non-metallic character is increasing, right? Okay, so this is the full-fledged answer here. This is the full-fledged answer here. You can see this. Okay, so you can see this here, that this is the periodic table, right? As I told you, instead of learning this thing, you can just simply remember that size is inversely proportional to ionization enthalpy, inversely proportional to electron affinity, inversely proportional to electron negativity, is inversely proportional to non-metallic character, is directly proportional to metallic character. Okay, size is increasing down the group, so metallic character is also increasing. Size is decreasing along the period, so non-metallic character is increasing along the period, right? So this you must remember, right? This is a very important conclusion from today's lecture, right? This is a very, very important conclusion from today's lecture. Okay, yes, yes, students, right? Okay, now the conclusion part here, ionization enthalpy extreme left in a period is least, electron gain enthalpy on extreme left is highest negative. Can you tell me why? Right? These are the things, the maximum chemical reactivity at the extreme left among alkali metal, That means the maximum chemical reactivity at the extreme left element is exhibited by loss of electron leading to formation of cation, and at the extreme light, basically they are saying that this is the same thing, that electron affinity is least in the left side and maximum on the right side. Similarly with electron gain enthalpy, also maximum on the right side, least on the left side. Here they are saying that if this is the periodic table, then these elements would tend to make cations. They will try to make cations, and these elements will try to make anions, because they want to gain the electron, they don't want to gain the electron. That is why they will form cations, they will form anions. Okay, right? Understood? This is also the same thing, right? I have told you this in a simpler way, right? You can go through this, metals, non-metals, everything, right? Then the last part is diagonal relationship. Now in diagonal relationship, what we observe, that we know that this is lithium, beryllium, boron, right? What is happening along the period size is decreasing, right? Down the group size is increasing. Again here size is decreasing. So what you will see that conclusion what we saw here, that lithium and magnesium, they had diagonal relationship with each other. How they had diagonal relationship? Because here the size is increasing, right? Let's say, I'm just going to tell you with a simple thing. Let's say this is 9, this is 10. Achha, this is decreasing now. This is, let's say this is 10. This is, by decreasing, this is 9. Okay. By decrease, this is increasing, so that will be 11, right? And then again it will decrease, so it will be 10. Can you see it is similar? I am telling you by just simple numbers. Okay. Otherwise, the concept is more complicated. Here you will see that, okay, ma'am, that was very simple. So what is happening here? We can see that here size is decreasing. Firstly, size will decrease. Here size will increase. Then again it will decrease. So what will happen? The size of this magnesium and lithium will be approximately same. The size of beryllium and aluminium will be approximately same. The size of boron and silicon will be approximately same. That is called diagonal relationship, right? Lithium will match the properties of magnesium, beryllium with aluminium, boron with silicon. So you can say the similarity in properties of definite pairs of diagonal adjacent element in second and third period in the table. Similarity between lithium and magnesium, that is diagonal relationship, also exists in other pairs as well, right? Okay. Then we'll see that diagonal relationship arises because of which of the following? On descending a group, when in a group, what is happening when you're going down? The atomic size is increasing, right? On moving from left to right, the atomic size is decreasing. On moving diagonally, the size remains nearly constant, right? That I told you with the help of the simple numbers. Okay? Okay, students. I think that is clear to you, right? Size ratio is similar. Acha. This is also a very important concept here, right? If you want to study, right, this we have done, the size we have done, right? The size we have done, that how it is approximately same, right? Because here what is happening, lithium, right? Lithium and magnesium is having same size, right? Lithium positive and magnesium 2 positive are also having the same size. So that's how they have the same size, right? Second is diagonal similarity in electronegativity values. So what you will observe that lithium and magnesium have same values, beryllium and aluminium have same values, boron and silicon have same values, right? Their electron negativity values is same. Next is charge by, this is the most important reason, right? That is charge by ionic radius ratio is approximately same, right? So if you see charge by ionic radius ratio, right? For example, let's talk about beryllium 2 positive and aluminium 3 positive, right? The charge is 2 divided by 0.45 and here the charge is 3 divided by 0.53, right? You will see approximately they will have the same value. So when the ratio of ionic charge by ionic radius is same in between these elements, that is why we can say that they have diagonal relations. So what we have observed, that beryllium 2 positive and aluminium 3 positive, they had the same charge by the charge on them and the ionic radius, right? That is same, but the charge by ionic radius is nearly similar because of charges are 2 positive and 3 positive respectively, right? So that is the reason here the diagonal relationship is there. So basically diagonal relationship arises because of the size only, right? But this is a very, very important application that they can ask you, that the radius, the ionic radius is not same, then how you can say the size, they have any relationship, right? So diagonal relationship is not that ionic radius is same. It means that the charge by ionic radius should be same. They don't have the same ionic radius because they don't have the same charge. If you divide charge by ionic radius, that will be same. Okay? Understood? Yes, students. Everybody, is that clear? Okay, these are the questions only. Okay? Chal. And students, that's it for today. That's it for today, students. Now, very important thing for all the students. See, this chapter, how many hours we took? 3 hours. Okay. Now, in 3 hours, right, how much I could have told you. So, I don't know what is your level right now, right, for JEE 2026, right? Maybe you need more detail, maybe you need less detail, maybe you need 1 hour session, maybe you need 10-hour session. I have no idea, only you know that thing, right? So students, the thing is, if you right now you feel that, ma'am, I was able to understand what you were telling, but ma'am, is there more detailed lecture that I need? Ma'am, is this enough? See, beta, this was just a revision, okay? The way I will teach in 10 hours or 15 hours is very different of the way what I will teach in 3 hours, okay? So this chapter, if you want to do it in detail, like the core detail, you want to do every single part. See, there are more to this chapter. There are different oxides and hydrides. Most of it I have covered, but there are other things as well, like screening effect, how to calculate the sigma value. All those things are there in this chapter. But those things, right, cannot be taught in 3-hour lecture. Right, there will be separate 1 or 2 lectures of screening effect only. There will be separate lectures of only ionization enthalpy. There will be 1 lecture of electron affinity only. Right, that's how we teach in our batch. Right, so everything, right, will be in like more detail, and I know that you want more question practice. Right, so in our batches, we teach questions. Right, you can see that why, ma'am, ionization enthalpy you can teach in 15 minutes also, then why, ma'am, 1 hour for ionization enthalpy, so that we can take up the questions of ionization enthalpy. We can take up different previous year questions. We can take up level 1 to level 4 questions of all the concepts, right? That is why in batch it is theory plus more practices there, right? And what is the name of that batch? The name of that batch, you can see it here. That is our own Sigma batch. You can see this here. Sigma JEE 2026 batch. You can click on here. And this is the batch which is available to you at 4999. See, for example, I talk about one chapter, that is structure of atom. Now, structure of atom, how many classes is needed, right? If you actually want to study from the very base, right? From the very base. From the basic level, if you want to study structure of atom, you need at least 9 to 10 lecture minimum, right? Along with the question, along with the quizzes, along with the leaderboard, everything, right? You need proper mock test, you need proper test series, right? For that, we have this batch, right? Okay, so those students who want to have full-fledged revision, full-fledged batch where we are conducting the live sessions, where you can ask your doubts in the live as well. You know why in the batch the classes are lengthy, like more time is needed? Because in the batch we answer every single doubt. It's not like I don't want to answer it on YouTube, but on YouTube we still have a limited time, right? So either I'll answer your doubts or I'll teach, right? But in the batch there is no such restriction, right? So every single doubt will be answered in the class itself. For example, you are watching some recorded version, then in that recorded version also, right, you can ask your doubts. Yes, in the recorded replay version also you can ask your doubts. So that is one benefit of a batch, that you can ask your doubts, right? That will be resolved within the class only. Second important thing is there will be continuity, right? So it's not like the classes will be cancelled or anything like that. It will not be there. Even if I want to cancel my class, I have to inform the team 1 or 2 weeks before the class, right? Only in case of some emergency, I'll cancel the class, but that too I have to take the class within 1 or 2 days, right? So it is more of about discipline from the students as well, because when you are in a batch, right, you have paid. See, one simple thing is, if someone gives you some chocolate cake for totally free of cost, you might eat 1 or 2 pieces, and maybe you will be like, okay, theek hai. Even if you know that chocolate cake you didn't like that much, even then you will be like, okay, I don't like this, I'll leave this chocolate cake. But if you purchase that chocolate cake, right, then you will be more, you know, attached to that. You will be like, okay, I have purchased it, I'll eat it. Let's talk about gym membership, right? So we have seen that whenever we go for a demo class, this has happened with me also, right? So whenever you go for a demo class, you're like, okay, I have not even given money, then why to wake up and go? But when you give the money, you're like, oh my God, I have already spent the money, I have to go, I have to be there in the class. So that's why we are charging you this minimal amount, so that discipline should be there from your side as well, that yes, I have invested some amount here, then I'll take the class daily. So daily there will be classes from Monday to Saturday. Sunday there will be mock test every 15 days, right? And that mock test, right, a report card will be there, that what are the changes that you need to do, right, in your preparation, that will be there after the mock test analysis, right? And if you want to give your test, like random days you want to give the test, then students, we will have a test series also. So you will have 40 part and full syllabus test, right, in the class, right? Okay, yes. And also within the class also you can ask your doubts, and there will be doubt sessions conducted, there will be previous year session conducted. And if you're thinking that, ma'am, what about modules? Modules will be provided to you. So there are tattva modules that we will provide you. In that level 1 to level 4 questions we have, right? And let's say you have completed one chapter. So without practice, it's nothing, right? So practice you will do from those modules, and teachers will themselves tick that these are the important questions that you must do. Rest of the questions you can do, or it's totally your choice. If you want to have more practice, you can do. Rest you can leave also, but important questions will be marked by the teachers only, right? Okay. So guys, that's it for today. This is Diksha Kaushal signing off, and I want all you guys to, you can see the Telegram channel here, right? This is my Telegram channel, right? You can go and follow that Telegram channel. And this is the Vedantu JEE English official Telegram channel. You can scan the QR code here, and you should follow both the channels here, because here you will get all the updates, and here you will get the updates regarding chemistry and JEE exam, right? And this is my Insta handle, that is chemcatalyst_Diksha. You can also follow that for more interactive sessions, or if you want to, if you have any doubt, you can always ask me that doubt on the Insta handle. Okay, students, and I'll take your leave. Teacher, when students don't interact with the video, this is me right now, because I can see you guys are only focused on chit-chatting with each other, and this is me right now, right? Because it is very disappointing when you guys are chit-chatting, you guys are not interested, right? So I would not want to have that culture in my class. So let's be more respectable towards the teacher, and let's make the class more interacting, right? Not a dull, boring class. Okay, I understand you love words, let me tell you one thing. If you guys are actually lovebirds, if there is someone who is thinking that I'll make girlfriend and I'll make boyfriend from a YouTube chat, okay, let's imagine, right? You're able to make girlfriend and boyfriend. Then why your girlfriend and boyfriend is chatting with you on a YouTube platform? Tell me that. What is that girlfriend or boyfriend who are not giving you their Insta handle, who are not giving you their WhatsApp number? And you are thinking that they will be like, oh my God, my lovey dovey. What you guys are thinking? Are you guys so innocent? You don't even know what is that person, like who is that person, that may be a 50, 60-year-old guy, right? Who is just chit chatting for you just for fun. What you guys are doing with your life? Huh? So don't do this, right? And please, I request all of you, I understand you make friends on YouTube chats, but please don't share your personal information with a random stranger. Please don't do that, right? You are very innocent, you are very you are like kids to me, you are like brother and sisters to me. So that's my advice to you. Please don't do that. You will fall in a trap, right? And you don't trust people online, right? It's not a good world to be trusted, right? To trust people online, right? It's a very it's Kalyug, where you can't even trust a person that is in front of you. Then how can you trust someone from a YouTube chat? What are you doing? You are wasting your time here, is it? It's not because of that's the first part is I am getting irritated when you're talking with each other. Second thing is I don't understand what is in your head. Third thing is I'm scared that what if you share your personal information with them? What will happen? Right? So please, especially girls, be aware, right? Okay, especially girls. And right now for boys also, it's not a good time, right? It's not a good time for boys as well. Be safe, right? Be safe from cyber affairs also that is done. So please don't make, like I say, stranger friends you are making here. Don't do that. This is a platform to study here, right? I am teaching you, try to learn something out of it, right? That will be better for you. Otherwise, if you think that someone is in love with you, like totally crazy about you, they specially come to chat with you, then ask them why they are not giving their Insta handle to you. Why you have to chat publicly with them? I don't understand that, right? So be aware of these things, right? Okay, sure. Okay then students, bye bye. Take care. See you all in the next class. Bye bye.